Welcome everyone. So let's start. Today's session is about subnetting. It is a 2-day short course on subnetting. This is what you guys have been requesting from long time. Also our classes which are ongoing. So last weekend they also requested that they want to go for subnetting. So we thought let's hold our detailed session today and tomorrow. So this is a 2-day session. We will do subnetting in detail. So please watch the full recording and try to join the live session because this will give you good experience. So we will go through subnetting in detail and we will see how to do. So I will first explain you something about, there are total 7 sections of, so I will explain you about basic fundamentals of IP subnetting, that why we need subnetting at all. Because what happens in most of the trainings, people just start doing the math, which becomes very boring, and then we don't know what is the purpose, why we are doing all of that. So I would like to explain to you why we need subnetting with the help of these examples I have prepared for you guys. Is my voice clear, guys? Honesty says he has bad voice. Sometimes it is due to internet connection as well. Okay, thank you already, Jubair. Okay, don't worry guys, it might be sometime your internet issue as well. So don't worry, this session is being recorded as well. Just wait for a while, and then when your network connection is fine, it goes good. Because if you start writing here, it's better to write, but you know, we should see whether other people are also looking at the same issue or not. So we'll go through subnetting, why we need subnetting at all. What is IP address? What is subnetting? Some fundamentals. I'll give you an example as well of our roll number, our classes, so that it becomes, so that we have, for example, a big class of 100 students. How can we divide this class? Similar to the dividing a network. Then we'll see these examples. The second section, we will go through the IP address classes, how to identify, because this is the basis for subnetting. Although we have done this many times in our previous lectures, but I would recommend that we go briefly through it so that the people who are joining for first time, they can also study this one. We'll go through the exercises, but I will not go through in detail of the first few sections. Then we will go through decimal to binary, which is also preparation for the subnetting. This is not the subnetting, this is just the conversion which we should know. Although we can do by using a calculator. I will also show you how you can use calculator, because beyond CCNA, CCNP, we don't do the binary math by hands. We just understand it, and then we use the subnetting calculators as well. I'll show you how to use those calculators and all of that. Yes, guys, please turn off your video. It is wasting your data as well, and also sometime, you know, it might compromise your privacy as well, because sometimes you don't know your video is on. So from your side, video is not needed. From my side, I'll be sharing my screen. So it will save your data as well if you are not on Wi-Fi. But it's your choice, it's fine. So then we will go through the conversion from decimal to binary, and then binary to decimal. I'll give you some exercises as well to do at home. But this is again the preparation. Then binary to decimal, part number 4. Then from part number 5, the actual thing will start. We will start knowing about the subnetting in detail. So first 4 parts, first part I will emphasize, then second, third, fourth, which is about converting binary to decimal, decimal to binary. That one we have done many times previously as well, so I'll not spend much time, but we will go through it briefly. Then here we will know how to calculate the number of hosts in a subnet. Yes, it is being recorded, guys, don't worry. So, and it will be shared with you. So after that, we will do some examples. Then I'll give you some exercises to do from home. So it's a lot of extensive work which you guys will be doing today and tomorrow, and it will clarify all your concepts. And I'll be more than happy to take all your questions. So feel free. And then we will be calculating the range of the IP addresses. For example, if somebody tells us that this is the IP address 192.168.0.1. So how do I know from which subnet, from which network does it belong to? So we will also see how to do this one with the help of examples, and then there will be exercises again for you guys to do from home. So you guys can print this PowerPoint, even you can do it here, or you can do it on your paper or on your Word as well. And then you can send me your completed assignments as well, all of these exercises. So I will check, and if any problem. Then we will go through the real world scenarios based on all previous things which we would have learned until here, we will know how to do it practically when your manager, when your company says that we have purchased this subnet, please divide it into two networks of 126 hosts each. How do you do that one? So this is the real thing which we need to be expert on, but this is the highest thing of subnetting as well. I do not expect from you guys to be expert on first day. So it's okay, take your time, but we will do step by step. So your base must be very strong. And then we will go through these scenarios. We have a big network of 254 hosts, and we have to divide it into two networks, two small networks. We'll also go through an example. We have purchased this subnet for our company, and we need to divide this one into these subnets according to the requirement. We will do some binary math and everything. And then another example. And then I have given you these scenarios as well, which you guys have to prepare and send to me. Then there is an online subnet calculator. I will show you how to use. So you can click in here. This is on our website, and it has been programmed to do the calculation for you guys. Click on this one, or you can search in Google as well for IP subnet calculator. In this subnet calculator, actually, here you have to put, for example, I want to find that this 192.168.0. let's say 8, and the subnet is /30. So what is the range of the IP address? How many hosts do I get? So I'll show you that how to use this calculator. But actually we need to do the binary math and calculation so that we can understand that how the whole purpose, how the whole mechanism work. But once you are expert, like we are not doing binary math these days, that's why most of the people, they lag, because they start using the calculator from day one, which is not a good thing. So we will learn, and then we need to be efficient as well, because we cannot do binary calculation ourselves. So we will learn that how to use this calculator as well. The link of the calculator is also in your PowerPoint. Let me paste here as well. Also, whatever we will be discussing, studying, then all the materials, everything will be shared with you guys. Then there are many quizzes, cheat sheets, all of that, which will be given to you guys. So you guys can download. Also, this is the cheat sheet for the cramming, for the reference as well, the classes of IP addresses which I have prepared for you. And then this is the cheat sheet. I will also show you how to use this one. So these kind of help materials are also there available. Also, we will go through a live quiz which you guys will attempt, and we will see how much have you learned. Once we have done half of it, then the remaining you will do through the exercises. So let me go to the quiz, just a second. This will be the quiz which you guys will be attempting. It is an online quiz, so that's why I was saying that the recording is not 100% helpful. Better you try to join online. So here you will put your email address, and then you will be attempting the quizzes like that. So let's start now. Any questions until here, guys? Any comments, any questions? Please write it shortly so that we can read quickly and we can answer quickly. Clement says, can I help you with the lesson because I'm at work right now? No problem. I mean, anyone else, guys? Any question, any comments before we start? Idris says, can we record? No, it will be recorded. It is being recorded and you will get the recording, because if everyone starts, then Zoom will hang. Okay, already just Daniel Kumar says, all good. Okay. Okay, great. So let's start. So first we start with fundamentals of IP subnetting. These are the most important things which nobody tells, and each training, each instructor, they start jumping into the binary mathematics and everything. So, but we need to understand, first of all, why do we need subnetting? Why do we need to do all of this, right? So does anyone know why do we do the subnetting? Why don't we only use the classes A, B, C? That's all. Question and answer sheet. Lemon, which question and answer? Yes, you will get that one. Reduce wastage of IP addresses. Very good, Mohammed Hamid. Mr. Joel says to specify IP. Binzer says save addresses. Bori said save addresses already Jupyter to avoid congestion to do divide the network. Kareem track, Shiniza, Muse separate. Okay, very good, very good. So what is a subnet first of all? What is an IP address first of all? Subnet is a network. And what is a network? Last time we discussed in our lecture that what is a network? A network, you can say, is simply a switch, or a network is a broadcast domain where if one computer is connected, let's say this is a laptop, this is another one, laptop number 2, then this is a laptop number 3. If 1, 2, and 3. If laptop number 1, if host number 1, laptop, computer, host, server, they are all the same term. So when I will say host, then it means it's a computer or it's an any end device. So when one will send, then everyone else will receive a copy through the switch. This is called a network. This is called a subnet. It means a switch, basically a layer 2 switch creates the network. Then we have a second type of device which is called as router. So what happens in the case of router? If one side sends a broadcast, then it will not be forwarded to the other side. So if this one sends the broadcast, then it will not be reaching to 5. It means the routers, they divide the broadcast domains. There was a lecture on broadcast and collision domains in which we have discussed in detail. So please go through that recording as well. It will clarify your concept. Also, there is a very good lab and a lecture on switch versus router and how many types of devices are there in detail. So you can also go through if somebody is lacking on these concepts. So this is called a subnet. Now we want to divide these subnets. So we will need a layer 3 device in between them for them to communicate. So in simple words, each port on a router is a subnet, is a network. This is network number 1, network number 2. While all the ports on a switch belong to only one network. Clear? So what is a subnet now? Again, subnet is a network in simple words. It is the logical subdivision of an IP network. Means we have a network and we subnet it. We make a subnetwork out of it. We have a big network, right? And then we divide this network so that on left side there is one, on right side there are 2 networks now. Network number 1, or you can say subnet number 2. That's why you can say IP subnetting. Subnetting means subnetwork, right? Now there are 2 parts of the IP address. Everyone know IP address is a number which is assigned to a host to each port of any layer 3 device. So IP address has 2 parts. Usually we write the IP address like this: 10.0.0.1, 255.255, any subnet, any network mask .0, which can also be written like this /24. So it has 2 parts. First part is called the IP address, and then the second part is called as the subnet mask. IP address is the number. It tells us the host number, while the subnet mask tells us from which network does it belong to, right? Again, part number 1, part number 2. First part is just a number, and then the second part, it tells us that it belongs to which network, where does it reside. For example, let's say we have these 3 networks, right? We have network number 1, we have network number 2, we have network number 3. So there are 3 networks, and then there is a 4th network as well, but we don't care. This is point-to-point link, right? So this network number 1, it has around 30 computers connected to it, which are all in the same IP subnet. And the IP addresses, they start from 10.0.0.0 until 10.0.0.31. First and last IP address cannot be used. So the first computer will have an IP address of 10.0.0.1/27. Then the second one will have 10.0.0.2/27. Guys, these basic concepts are very important. Any question comes into your mind, please ask, but let's keep the questions relevant to what we are studying. Then the third one will be .3, .4, .5 until it will go to .30. Here it is showing 5, it is just for the symbolic presentation, but totally they are 30 hosts. So total 30, and then What would happen if I do not put /27? This one will start from 10.0.0.33, 34, 35 dot /27 means the network number. We will study this one as well. So this is the subnet mask, which is the second part. If you are missing this one, please go through the lecture of IP addresses. We have discussed this in detail, that IP address has two parts. One is called IP address. The second one is called as the subnet mask. So if somebody is joining this first time, it's no problem. You can send a message to admin. She will share the recording of that session. So IP address and subnet mask. If we do not put subnet mask, then what would happen? You know, if this subnet mask is not 27, what would this mean? So if I say 10.0.0.0/24, this number is very much different from 10.0.0.0/27, because this 27 tells us that there are total 30 hosts which are starting from 10.0.0 until 31. While this number tells us there are 256 hosts which are starting from the first IP will be 10.0.0.0, 0.0.1, 0.0.2 until .254. So subnet mask is very important to know the location. If I tell you that this is the IP address, so can somebody tell me from which network does it belong to? Network number 1, 2, or 3? Anybody can tell? Vasu, Jonathan, Brian. Sorry, I wouldn't be able to take all names because we have many people now. Terence, Ken, Asiant, and Casimo 2. Yes, you guys are. Some people are saying 1. No, it will not be 1. It will be 2, because you can see from the range here 10.0.0.0 until 31. This is called as range. So this means the first computer will have an IP address of 10.0.0.0.1. Although it is 10.0.0.0, it starts from here, but first and last IP address cannot be used. First one is called network number, last one is broadcast number. The second IP address, second computer will have this IP address 10.0.0.2 until 30 and 31. We can see from here it is starting from 0 until 30. This is called as range. We will see how to calculate this range. We will see everything. Here I'm just giving you an overall idea. So if we do not have the network subnet mask, we don't know. Let me give you an example of this one in general world. Here we have the roll numbers. So these are the roll numbers of our recent two classes, batch number 25 of CCNA and batch number 26 of our CCNA class as well, right? I just copied from the original roll numbers. The roll numbers we always put like that. Here you can see in this CCNA batch 25, you can see these numbers are fixed. They are not changing. And then these roll numbers 1, 2, 3, 4, 5, 6, 7 until how many roll numbers can we have, guys? You following this scheme? Total, how many roll numbers can we have in this class? Because we are using 2 bits. No, Boris said I have mentioned 15, but there will be 16, 17, there will be. But how many can we have total? It can be 100. It can be from 00 to 99, right? Because we are using 2 numbers. So maximum it can have 16, 17 until 99, because for 100 we will need 3 numbers which are not here. So we are having 2 numbers. So it means we are using 2 numbers. If we use 2 numbers, we can have total 100 roll numbers, 100 people in one class, right? Then again, if the people, they become more than 100, so what do we have to do? We have to make a new class like this. Then we start again 01, 02, 03. Or what we can do is we can change 1 bit. We can add an extra bit. So then we can start putting in here. On the left side, we can say 001, 002, 003. Now, in this case, with 3 digits, how many students can we have in one class, guys? Very good. Daniel says 999. Yes, this will be now. The last one will be 999 because now we have 3 digits. So now you understand the importance of digits. If we increase the number of digits, it means the part which is changing can have more people, can house more things, but then we have to decrease. If our numbers are fixed, let's say 32, then it means we have to decrease something from here. So we have to cut one digit from the other side and borrow to the other side. So in here, you might have seen that within one class, there are two parts now. Each roll number is telling us two parts. First part is fixed. This part tells us that this student belongs to which class, to which area, to which group. And this part is fixed. You can see this one is permanently fixed, right? Then there is a second part on the right side, which is changing again and again. This part is changing. And then this represents what? This represents the student number. Similarly, in IP addresses, we have one part which is changing, which is called as host part, and one part which is not changing, which is binding them together, is the network part in the IP address. Daniel says, question, CCNA B25 is actually the mask number. Yes, you can say this one is the network portion of the mask. Mask basically tells us that which part is the network number, which part is the host number. So mask is used for that one. But each IP address has two parts. One part is fixed, which is again this one. And then another part is changing. But you can see the part which is changing, that one is being repeated again and again. You can see 01 is here, 02 is here. But we can differentiate. Why? Because this part is different. B25 and B26. It means the student which belongs to the class of CCNA batch number 25 is different from the roll number 1 of batch 26. Similarly, batch 27. So these are called as groups, or you can say subnets or networks, or our course classes as well, right? Similarly, in IP addresses, we also have two parts. One is called network portion and the other one is called as host portion. Host portion keeps on changing while network portion does not change. Network portion tells us that if we have one network, two network, three network, that from which network does it belong if they are connected together, right? So the current standard of IP address is RFC 791. IP is a protocol actually. IP is a number. IP address is a number, and internet protocol, IP is a protocol. I would suggest that anybody who really wants to study networking, who wants to adopt as a career and who wants to proceed and become a real network engineer must study this RFC. RFC are standard documents which are released by IEEE or IETF whenever they release a protocol. So when I was young like you, I was studying this IP protocol and I still have those notes. IP protocol, OSPF. So you must study all of those basic ones, especially this IP, because this is the base of the whole networking. Okay, so IP is a 32-bit number. We all know it is written in this format, 10.0.0.1 or 192.168 like that. But actually, this is based on the binary calculation. Each of this digit is 8-bit number. So means it can be represented in binary in this form as well, because 10 in binary is 1010. Then 0 in binary is this, 0 in binary is this, and then 0 in binary is this. So this is how it goes. And then we have subnet mask, which can also be written in binary. 255, we just convert. We will just see how to convert it. 255. So what I want to say is we can write them in decimal notation or we can write them in binary notation as well. And we need to know that how to convert. Yes, this one is 0, typing mistake. This one is 0. So it has two parts, which is network number and host part, and subnet mask tells us. So the subnet mask until where it goes with 111, it means this portion is the network portion, and then where it has zeros, it means this part can change, and this is called as host portion. Again, the part which is changing is called as network portion. This tells us from which network does this IP address belong to. While the portion which has zeros in the subnet mask is called as host portion, and then it keeps on changing. So first IP address will be what? 0000, just like we saw in the roll number. The second IP address will be what? 0000.2, 00003004 until it finishes up, right? Now IP address is represented by dotted decimal notation, means 10001 or 192.168, something like that. But actually these numbers are binary numbers, you can see. I just showed you an example. Then two types of addressing, classful and classless, right? So let me go quickly to that page of classes. Okay, so each class has a fixed subnet mask, which is called as default subnet mask. Means if the IP address belongs from this range, if the first octet is from 1 to 126, then it must have this subnet mask. Subnet mask can be written in dotted decimal notation or it can be written in slash notation as well. CIDR notation, you can see. So it means if 1 to 126, if an IP address is 11.0.0.1, it means this belongs to class A. So the default subnet mask, it should always be /8. This is called class full. Now, if the same IP address, we mention it 10.11.0.0.1, if I mention /9, now this is no more class full. This one is now classless. Right? So if an IP address has a subnet mask other than its default subnet mask, other than 8, other than 16, other than 24, then it is called as classless. Clear on this point of classful and classless? Also your questions which come into your mind, please write, please keep on writing with you, because sometimes if you write long questions, I can't see and when I'm teaching. So I will try to answer if they are short. But long questions or scenario based question, please keep on writing with you. During the break or in the middle, I will take your questions, then you can paste again. So I'm not ignoring any questions. I want you guys to ask questions so that you learn. We will come to classes now. So I just wanted to tell you classful and classless. We'll go back again there. Right? And then first and last IP of each subnet is not usable. These are some of the rules which we need to learn if we want to learn IP addresses and subnetting. And without IP addresses and subnetting, you cannot be a network engineer. You cannot learn anything. So first and last IP of each subnet is not usable. We cannot assign to any host. For example, if the range of a network is from 10.0.0 up to 10.0.0.3, it means the first IP address will be 10.0.0.0, the second will be 10.0.0.1, third will be .2, and fourth will be .3. Now in this network, the first IP address cannot be used. It is called as network number. It means it represents this whole group. If somebody asks us that this range belongs to which group, so we will say it belongs to 10.0.0. Means the first one is the name of the whole network, and the last one is called as the broadcast. If you send any communication to this IP address, it will go to everyone else as well. We will go to classes, Samson, don't worry. After this one, the second part. So first cannot be used, last cannot be used, only middle part can be used. So if somebody has 256 hosts, so it means we always have to make sure if somebody asks how many usable, we have to -2 always. And -2 is because the first and last IP cannot be used. So out of 256, we can only use 254 always, right? And I already explained IP and subnet mask, how they can be written together. We went through this example as well of the class roll numbers to understand the network and the host portion as well. Now let's go to an example. Let's say you have a class of 100 students, right? Yes, we are studying everything. VLSM, CIDR, all. So we have a class of 100 students. Either we can have it in one large class, or what we can do, what usually the schools are doing, so they divide it into two parts so that it's easy to manage, it is easy to identify students, and it is easy to understand. Yes, we will go through 1 to 7. Guys, please don't jump. Let's discuss what we are discussing, and please keep your questions with you as well. Okay, so either we can have one big class of 100, or either we can have two small classes of 50 students each. We can say class 1 and class 2 for easy management. Or what we can do is we can also make 8 classes. So we can further divide it into 25. 25 means two classes of 25, 25 and one of 50. Or we can divide a class into, let's say, 25 and then 25. So either we can have 4 classes. So this is called as subnetting. We keep on dividing the subnets into further smaller networks for easy management and according to our requirements as well, based on the scenario which I told you on switch and router. Right? Similarly, let's say you have this class 192.168.0.0, you have this network. This network /24, later we will see in our example when we will calculate the number of hosts. So once we calculate, we will know that /24 means 256 hosts are there in this subnet, right? So either we can keep big subnet, but if somebody has a requirement, your company or your management has a requirement, and why do they have requirement? We will see in the scenario as well, which will be coming next. Let's say we have a requirement to divide it. So what we can do is we can divide these 256 hosts into 128 each. So this one will have 128. This one will also have 128. We can have network number 1, network number 2, 128. But ideally it will be, but practically it will be 126 because we discussed the first and last cannot be used. So you can see that this portion is same 192.168.10.0.0. But what is making the difference between them? From 24 we have made it 25 now, because we know /25 always has 128 hosts. We will do the calculation in next step as well. So this is called as subnetting. Further, if we want to divide this one into, if we want to divide it into 4 subnets, so we can also divide this one into 4 subnets as well. So we can say the first one will be 192.168.0.0 / this one will be 128, sorry, it's a spelling mistake, typing mistake. Okay, 192.168.0.0, the first one will be /0. The second one will be 192.168.0.64/26. We will see this with practical example how to calculate this one. .0. Let's say 128 or anything, and then /26, and similarly the fourth one will be. So you can see this portion is making the difference, although the number is also changing, but we will see how it goes. In simple words, we can divide a network into multiple further network according to our need. If your company needs one full subnet of all 256 hosts, it's okay, they can start using this IP scheme. The first IP address, let's say they will put all the computers together, they will connect them through a switch, and the first computer will have an IP address of 192.168.0.0 cannot be assigned, so it will be 1/24. Second will have 2/24. Third will have 24. They will go until 254/24 because 55 cannot be used. But what will happen now? All of them will be able to communicate with each other. They will be in one group. But if somebody says, no, I don't want to put them in one group, I want to divide half and half. So from 1 to 128, they should talk. And then from 128 onwards, they shouldn't be able to talk to the first one. They should be able to talk to the other side as well, right? So in that case, we can divide it into 2. We can change the subnet mask from /24 to 25. And then first one will be 0.0, second will be 192.168.0.128. But we will see practically. Now here, why we need to do subnetting? Let's study again one more scenario. So in simple terms, if we say, let's say your company has given you this network. They said, okay guys, we have purchased this one from Ayana from the registry, and we want you to implement this 110.0.0/24 into this network. So now the challenge comes, because now it's not in your hand. Why? Because now you have routers in between. As soon as you try to configure 10, let's say you want to keep in one class, right? 10.0.0.1/24. If you go to the other side, if you try to assign 10.0.0.0.2/24, is it possible? No. It will give you the error if it is the same router, but it will allow you to configure, but then there will be conflicts as well because networks are overlapping now. You will have suboptimal routing, there will be security concerns, there will be bad performance, and network will not work properly. But if it is on the same router, let's say this first IP address, because on router you also have to give IP address, right? So on this side you try to give 10.0.0.1/24. On this side you try to give 10.0.0.2/24. Here router will straightforward reject. It will straightforwardly reject. It will say it is not possible because this is a layer 3 device. Each port should have a separate network. So it means you cannot go with this one. You have to divide it into the subnets, right? How to divide? That is what we are going to study as well. So the requirement is that there are 30 computers. Let's say this is your company's branch 1, which is in Dubai. Let's say this is in Dubai somewhere. Then this is somewhere in India. This is somewhere in Nigeria, let's say, right? So they want to connect them together. So they are saying in our Dubai branch, we have 30 computers, 30 hosts. Here we have 27 computers. Here we have 30 computers. And then we also have 2 additional networks. Guys, can somebody tell me how many networks are there in this picture? Last time we discussed the people who joined in our previous lecture of switch versus router. Very good. Some people are still saying 3. No, it's 5. Very good, Sheila, Philippus, and Casimo. There are 5 networks. Network number 1, including router port. Network number 2. So this is 1, this is 2. Network number 3. And then we also have these 2 additional network, this point-to-point network between the 2 routers. This is network number 4. Because of course, each port on the router, each layer 3 port needs to have an IP address. So total 5 networks. It means we have to divide this network into total how many networks? Total 5 networks. Some portion of these will go to here, 30. So total how many? For /24, I just told you we have total 256. We will see how to calculate later on in next phase. So here out of these 256, 30 will go here, 27 will go here, 30 will go here, 2 will go here, and 2 IP addresses will go here. But we need to divide, we have to make this number of hosts always in the power of 2. So we have to make them equal. So we will divide this 256 into equal subnets, but we cannot make it 5, we have to make it 10, because like I said, you can make the networks, either it can be 1 network, it can be 2 network, it can be 4 networks, 8 networks, 16. It cannot have 15 networks. It's not possible within one class, right? So we will divide this one. You can see here. I'm not saying we should know how to divide, because we are going to study it. This is what we are establishing the base for. Kelvin, you are requesting remote control, please. It is prompting here. So 5 networks, right? You can see we just changed the subnet from 24 to 27. We will see how to do it. The first subnet will be 10.0.0.0, which will address the 30 host. The second subnet will be 10.0.0.34, which will address the 32 host as well. 5 will be wasted, no problem. And then here we will have 30 from 10.0.0.64/27. You can see all of them, they are having the same subnet mask. It means when we divide a class, all of the smaller subnets, they need to have the same subnet mask. They cannot have different. They can have different, but then they will overlap. So we have to further divide it 2 times. In one time, we cannot. So it means it was 10.0.0/24. Total 256 hosts were there. What we have done, so we have given 32, 32, 32, 5 times. We divided it into the 5 subnet. The first subnet 10.0.0/24. It means this will start from where? The first computer will have an IP address 10.0.0.1, because 0.0 cannot be assigned. The second one will have .2, .3. Then finally it will have up to dot 31. So total 32, because 32 cannot be used and dot 0 cannot be used as well. Then the next phase will start. From here, we will have, sorry, 31 can also not be used, so it will be 30. It will be up to 31. So the second phase will be 10. The first computer in this network will be 10.0.0.33.34. This will be 35, 36, and the last computer will be up to 63. Then we go to this network. So it is starting from 64. Jonathan says, why is 27? Yes, we will go through. That's what we are going to study. This is, I am giving you overall idea that how to read the diagram, but how to do the calculation, it is not so simple. We will go through. We are establishing base for that one. So dot 64 means this IP addresses will be from where, guys? What will be the IP addresses in this subnet? Any idea from the picture? From where it will start? What will be the first computer IP address? Cannot be 63. Yes, very good, Salawu, Idris. Yes, it will be 65 because the subnet number is 64. So this whole network number is this one, right? So it means it starts from, and what will be the last one? 94. Very good, Temison. Some people are saying. So the first one you can see from here, but don't worry, we will calculate in detail. This is what we are studying today and tomorrow. That's why we have these extensive sessions as well. So please arrange your time easily if you really want to understand subnetting. It is not something which we can, otherwise we will be struggling like all other network engineers who become managers, who become directors in their companies, and then, you know, they are lacking the basic knowledge. So we have to have a deep dive into subnetting. Then the remaining concepts will be very easy. If you don't, then you will be struggling in OSPF, you will be struggling in BGP, you will be struggling in MPLS, you will be struggling in VLANs, everywhere, if we don't understand this in deep. So first will be 65, the second will be 66, and last one 67, 68, and last one will be, because it is starting from this one, so it will be 95, also because it is 32 host. This is how we do. And then this one, it will start from dot 97 and then dot 98. On this side, we will have dot 129, dot 130. That's all. So this is how, yes, Khurram, yes. So this is how we divide a host. This is the overall idea. I'm not saying that now you should know that how to do the calculation. So calculation we are going to study, but this is the overall idea. Means we were having this network which was giving us 256 hosts. So what we did, we divided into 5 small subnets. This one, and then this one. This is called as subnetting. Now I guess you guys know why we need subnetting. Is it better now, guys? So subnetting gives us, other than to fulfill our requirement, it also gives us easy network administration. Now you can see that this side people will be able to manage themselves. Also routing is not possible, you know, because we have to place router in between. So routing is not possible. We will have to place the switches in between, which is not our requirement of the network. We need to have routers. So it gives us easy network administration. It makes the network performance better. Why? Because within one network, we just discussed, it is one broadcast domain. When one PC will send some data, everyone else will receive that one through the switch. So we want to make it small. It means less broadcast. Also, according to Cisco's recommendation, any subnet, any network should not be bigger than 500 hosts. So it means this is the recommended range. It means if you have more than 500, then you will have a lot of congestion. And then this is for improved network security as well. You can see the network security means within one network, if one of the computer is compromised, if one of them is having virus, the virus can easily spread between, it can easily replicate it to all of them. So it is for improved security when this network is separate, and then this network is separate, this network is separate. Clear, guys, why we need subnetting at all? So that we move to our second section. of IP address classes. First one was about the fundamentals. Fundamentals mean that why do we need subnetting at all? We have an IP address and a subnet mask, and then we can divide them into we can distribute. This is just like, you get a big chunk and then from your supplier, and then you divide the salary to each of them. And then we went through the example as well. So we divide this is just like, you can think about the classrooms, we divide the classrooms into smaller classes for easy management. Whatever advantage we get from dividing the classes in normal schools, the same advantage you get by subnetting as well. And then we went through this example. So let's go to the second part, which is about IP address classes. We have 3 classes mainly. There are 5 classes, but we don't care about D and E. We care about C and A, B, and C. So how to identify? Very simple. So 3 classes I want you to know that how to identify. We discussed this in detail as well when we went through the IP address. So you just see the first octet. If it is from 1 to 126, you should immediately know that this is a class A IP address. And then you should also know that what is the default subnet mask for this one. It should be /8, means first 8 bits are 1. This is 0 and this is all 0. If the first octet is from 128 to 191, it is class B. From 192 to 223, it is class C. Right? So let me ask you a few questions now. Can somebody tell me which class of IP address is this? Okay, Seku, Vasio, Mr. Hacker, Robert, Sheila. Yes, this is class Com Erica. Very good. So this is class A, right? How about this class 172, if you remember? B, right? So I think you guys are very clear. So it is very easy to identify. This is class B and this is class A. So what is the subnet mask that I should put with this class A? With 10002, what should be the subnet mask? Philippus says 8, Shiniza, Sora, very good. So it should be /8. And then what should be with 172? Ebenezer, Jonathan, Daniel, yes, it should be /16. Very good. And then this 116 belongs to class A as well, right? So this should also be /8. Why? Because from 1 to 126 is always class A. And then 192.168 is class C, because from 192.0 up to 223 is class C. So it means this is class C and it should have /24. Very good. So you guys can identify easily. This was about IP classes. The people who were asking questions about classes, is there any further question, guys? Before you were asking. Okay, yes, 128, yes, you guys asked. So there are some IP addresses. Anything which is not here, don't worry about that. That does not belong to any class, right? So you can see from 1 to 126, there is a number missing. There is a number missing, which is 127. So we don't care. It might be loopback. It might be some reserved. So everything else which is not here, let's not start caring about everything. Why this is not there? Why this is not here? Everything else which is not here is reserved. You can also see there is something. So can somebody tell me what is not here? Because the total range starts from 0 to 255. So it means 0 is not here. It means the IP address 0.0.1 is an IP address, but this is reserved. So this does not belong to any class. Similarly, from 1 to 126, and then it is 128. So where is 127? 127.0.0.3. This is also reserved. We don't care. Then after 223, there are also IP addresses 224, which is multicast, 225. Yes, very good. Nicholas says 128 0 dot something. So everything else, guys, let's not worry about that. Everything which is not here is reserved, right? Very clear. Yes, so if you want to know the usage of each of those reserved ones, there is a list as well, which I showed you in the last lecture of IP addresses. So you guys can go through that as well. Okay, now basic things, decimal to binary conversion. But before doing that, let me tell you that this is not something which you will be doing for the whole life or remaining. So you simply have to go to your Windows calculator. In the Windows calculator, you have to click on this one and click on programmer. Here you can see that it tells you binary and it tells you about decimal as well. So if you want to know what is the equivalent of 32 in binary, so just click on decimal in here, type 3 and 2, and it tells you what is the binary, which is 0010000. It means you will use the calculator in future, but for now you need to learn that how does that happen, how does the calculator do, so that you have concept in your mind, right? So we have to use the calculator in future. So this can be done very easily, but let's see how it is done. So don't get your mind stuck into this one, but we need to know. So how it is done? We calculate from decimal to binary. Two methods, from binary to decimal, means from 0010 into the decimal as well. In binary, when we do the IP address calculation, we always consider that the binary number is 8-digit. Why? Because each octet of IP address is also 8-digit. So let's convert this 32. How have we done? So we have done our same old school method, which we were doing before. We just keep on dividing by the values of 2. I think every one of us has already learned this one in our elementary school, in our high school. So let's say we want to convert 32 into binary number. Khurram, it's same time tomorrow as well. Guys, it's a 2-day session. Please don't miss tomorrow's session. It will be on the same time tomorrow. So start dividing by 2. 2 16s are 32. How much is left? 0. Then 2 8s are 16. How much is left? 0. 2 4s are 8. How much is left? 0. 2 2s are 4. How much is left? 0. And then 2 1s are 2. How much is left? 0. Now whatever we have seen here is our binary number. So what is this? 1 0 and then 4 zeros. But like we discussed, the binary number is always 8 digits, 0 and 0. So the number becomes this one. So this is how we have converted 32 into 0 into binary. Clear on this one, guys? Let's do one more example. So let's say we want to convert 60 to binary, right? So what we do, we write 60 here. Let's start doing it. So we write 60 in here because this is what we are converting into binary, and we start with 2. Francis, you see this example, then you will see now. So we start with 2, right? So we say 2 30s are 60, then 2 15s are 30. Then we divide again. Okay, so after we divided, how much is left? 0, because we have divided fully and also left 0. Now when we divide 2 15, so 2 7s are 14. How much is left? 1, because we couldn't divide 15 to full, right? That's why 1 is left. Then again 2 3s are 6. This is just by simple division. 2 3s are 6, 1 is left. Then 2 1s are 2. How much is left? 1. Now we cannot divide further. So what is our answer, guys? This will be our answer. All these numbers, we start reading from here. So the answer is 1 1 1 1 0 0. How many digits are these now? 4 and 2 6. But we discussed already that the digits should be how many? 8, right? So we need to put 2 zeros on our side from left side. This is just like, you know, if I write 60 in simple numbers, or if I write 0 0 60, both are 60. If I write 100 or if I write 0 100, left side zeros don't matter. So this is how we do the calculation, guys, right? Then this is the exercise I want you guys to do quickly. Can somebody do binary for 53? Please take papers and pencils with you while we are doing all of this now. So please don't use calculator. Yunus says, why do we put 2 zeros on the left? Yunus, because the IP address, each digit, each octet is 8 digits. So we have to make it total 8. That's why we put 2 zeros to make it all 8. Guys, please convert quickly. 53 for me. What is the answer of 53? Then the remaining you will do as a homework. I'm waiting for you. But if you can do, it's also fine. Just try so that you learn the method. Okay, Daniel has converted to 00 Adomo, Mr. Hacker. It's very easy. Did you guys face any problem? No, I guess, but some answers are a little bit different. So let's see what is the answer. Let me go to the calculator. Very simple. I click on decimal, then I say 5 and 3, and then I can see it is 00110101. So whose answer is correct? Shiniza is incorrect. Johnny is correct. Shiza, you can see again. Just try to do it again, or let's do it together. Guys, whoever has wrong answer, so let's do it together now, right? We want to convert 53, right? So let's start with 53. So we start dividing by 2, and we will say 26 2s are 52. How much is left? 1 is left. Then we start again. 2 13s are 26. How much is left? 0 is left. Then 2 6 are 12. 1 is left. 2 3s are 6. 0 is left. 2 1s are 2. 1 is left. So what is the answer now? Very simple. Now, did you guys find whoever had it wrong? So we start writing the number now. 1 1 0 1 0 1, which is here also, you can see. And then we add 2 extra. Guys, whoever was asking why do we add extra zeros, because we have to make it 8 digits. So we have how many? 1 2 3 4 5 6. So let's add 2 extra zeros on this side. So it means 53 in decimal is equal to 00110101 in binary. So guys, whoever had it incorrect, is it correct now? Kuram, total session time will be around 2 hours or a little bit more than that today and tomorrow as well, because we want to do it extensive. Also, even after 2 hours, whoever guys will have questions, I will unmute you one by one. You guys can ask the question as well, so that we can talk to each other. You guys can learn more as well. So this is the extensive, just like a small lecture. So is it clear, guys? Why are you including forward? Masika says the last reminder. This is how we have to do. So we have to start from here. We have to include this number. This is the way. How do we do? Okay, very clear. Yes. So let's move. This was, now there are some exercises I want you guys to do as well. These are the exercises which you have to finish. So today after the lecture, do 170, 53, 153, 244, and then you guys can send to the admin as well. And then there is 75, 84, 143, you have to convert. It's very easy. Now the second part, this was from decimal to binary, means a normal number into 0 ones. Now, if somebody says, this is the part number 4 now, from binary to decimal, it means if we have a number which is, let's say, 10 in binary, let's say 000000 in binary, how to convert this number into decimal, which is equal to 2. So let's learn the method of this one as well, back from binary to decimal. So we have to convert these numbers. For this one, actually, you might have observed that on each slide, even on the previous slides, I have put this one. This is like a Bible when you want to do the subnetting and networking. So you must remember this one. This is a simple table whenever you want to resolve something, whenever you want to do your calculations as well, right? So Simply you write these numbers 1, 2, 4, 8, 16, 32, 64, 128, something like that. And then you start writing these digits up to here. So just start moving 1, write 1 below it, 0 should be here, 1. The number which we have to convert, we just keep on writing that number up to here. I missed one of that one as well. So this one is this. And then we need to multiply these numbers. So actually there is a multiplication between these two. We will do it when I write. I think you will understand more. So 1 multiplied by 1 is what? 1. 2 multiplied by 0 is 0. 4 multiplied by 1 is 4. Then everything 8, 0. Anything which gets multiplied by 0 is always 0. Then finally we plus them. So 4 plus 1 is equal to 5. Right? So let's do an example. Let's write ourselves. Then you will understand more. So here, what do we have to write again? So we have to write those numbers which were, let me take a different color. So those numbers were basically 1, 2, 4, 8, 16, 32, 64, and 128. Just keep on multiplying, making it double and double, right? And now what is our number? Let's write our number. So our number is this one. So let's put 0, 0, 0, 0, 1, 0, 0, and 0, right? So this is our number, which is in yellow. You can see here. So I have just mentioned this number in here. Then we multiply all of these numbers together. 1 multiplied by 0, 2 by 0, 4 by 0, 16 by 1, 0, 0. So what is the final answer now? 1 multiplied by 0 is 0. 2 multiplied by 0 is 0. Then 4 multiplied by 0, 8 multiplied by 0, 16 multiplied by 1 is 16. So then 0, 0, 0. So what is the answer? We need to plus all of these pink ones now. So 0 plus 0 plus 0 plus 16 plus 0 plus 0 is equal to 16. So the answer is 16. This number in binary is equal to 16 in decimal. Easy, guys. So now you know how to convert from binary to decimal and decimal back to binary. Okay, great. So let me show you another one quickly. So these are some of the things which you guys have to do for me. So can somebody help me to convert any of this number? So please do the conversion yourself. 0, 0, 0, 0, 0, 0, 1, 0. Please convert this binary number into decimal. What is the answer? Either you can use calculator or you can use this binary math. Okay, some people already know. Very good. Jonathan, always, Nikash, yes, very easy. Why? What we will do, we will just write those numbers below it, which is 1, 2, 4, 8, 16, 32, 64, 128, and then we multiplied by 0 multiplied by 1, 1 multiplied by, so everything will be 0, only this will be 2. So 2 plus 0 plus 0 plus 0 is equal to 2. So the answer is 2, right? That's why I gave you simple example. Now you guys need to print this one and you need to do this exercise and then send me the file as well. Okay, now the real math starts. Until here it was for kids, you know. Now you are adult engineers, now you are network engineers, now you need to start doing the calculations. So are you ready? Or I think we can have a break of 10 minutes so that the people who have to go for prayer, who have to do anything, they can go for that. So here we have to calculate the real thing now. So from here it starts a little bit. Until here we were just playing. We just needed to know the basics. So how long break do you guys want? 5 minutes is okay? Okay, great. And also guys, there is a quiz now which you guys have to perform. So please perform the quiz. And then we will have, most of the people are saying 10 minutes, okay. But the problem is with the people who have data issues, you know. Jonathan says 5. Okay. Philip, admin, please paste the quiz link. Welcome back, guys. So let's start. Let me revise. Well, welcome to the second part. So what we have studied is from section number from module number 1 until 4. Let me give you a quick revision on that one, what we studied until now. So we have studied fundamentals of IP addressing. We have studied the IP address classes, decimal to binary and binary to decimal. So we went through the basics, that what is an IP address and a subnet mask. IP tells us the host number and mask tells us the location. Then we went through that how can it be written, what is network and host part. I gave you an example of the class roll numbers as well. Then we have a class of 100 students. How can we divide it into two classes of 50-50 each? Similarly, we have a network of /24. How can we divide it into two networks of 120 hosts each? Then we went through a practical scenario, how to divide this one, and we divided it, but we have not gone through the calculation yet, that how to calculate these subnets. This is what we are going to do now in the next sections as well. Then we went through the IP address classes. There are 3, A, B, C. From the first octet, we can see if it's from 1 to 126, it means class A, class B, and class C. It should have default mask. If the IP address is found with any other mask other than the default mask, it is called as classless IP addressing. Then we went through some exercises. Then how to convert a normal decimal number into binary, means a normal number 1, 2, 3, 4, 5, any number into binary of zeros and ones. We went through our old elementary school method of division, and then finally we pick up all the digits to make it a number. Then we went through, these are exercises which you guys have to do from home today. Then we have binary to decimal conversion. We just have to remember this 1, 2, 4. 2 raised to power 0 is always 1. 2 raised to power 1 is 2. You can also write in this form, but this table you must learn by heart. Just keep on doubling the number from 1 to 2, 2 to 4, 4 to 8. Then write your required number below it. Multiply. Just put a multiplication. There is automatic multiplication in here. And then there is an addition of all the results in the end, which gives us number in decimal. So now the real math starts. We have to calculate. We saw in our original example that there are 32 hosts, there are 64 hosts. So how do we know? You guys were also asking questions. For example, when we went through this one, so you were also asking that how come we know that this one is giving us 30 hosts? How do we know from /27 that it will give us 32 or 30 hosts? How come we know that this one gives us 32 hosts? So how did we do the calculation? This is the step which we are going to learn now. So I hope you guys are ready. So I have prepared this in the form of practice examples. You guys have to do it. Then you close this. So first you have to go through it. Then you close and try to do the same example yourself on a paper and pen. Then you verify it with the calculator, and then you watch it again, and then you do the remaining exercises, right? I mean, you don't only have to do the exercises, you also have to do it yourself as well. So repeat it yourself after the lecture today. The question says, the question will come in this format. They are saying that we have this IP address 192.168.0.0/30. /30 means, is it a classless or classful? Which class does this IP address belong to, guys? Yes, classless, right? Yes, because the class is class C, and because from the first digit we came to know it is a class C, and it should be found always with /24. But it is not found with /24, it is found with /30. It means this is a classless IP address. The example is not good, but you know, this is easy to remember. So this is just like, you know, if a lady is found with any other person other than the husband, then it is called as characterless. So similarly here, it is called as classless if it is found /24 is the husband for all the addresses which are class C. So if it is found anything other than 24, it is called as characterless or classless IP address, right? This is how we can remember as well. Similarly, for 172, it should always be /16. Okay, so the question says that this one we have to convert 192.168.0.0/30. How many hosts are there? Right, so there are 3 steps, very easy steps, which we have to remember. Step number 1 says we have to identify the class of the given IP address. So what is the class? From the first digit, we can find the class is class C. Then identify the given subnet mask. The given subnet mask is /30. Given means whatever has been given to us to do the calculation. So it is /30, which is called as given subnet mask. I will always write given mask with GM. Now to calculate total number of hosts, very easy formula is 2 raised to power h. It means h is equal to 2 raised to power 32 minus given mask. So this is always a fixed formula. Number of hosts in an IP address is equal to 2 raised to power 32 minus given mask. So given mask is how much? Is 30, which is written in here. So 32 minus 32 raised to power 2, it means 4 hosts, which means that the IP address, it will look like this one. So this is the network 192.168.0.0/30. It gives us 4 hosts. So what would be those hosts, guys? Now we should be able to know. Those hosts will be 192.168.0.0, 192.168.0.1. How many usable hosts are we getting, which I can assign to computers? 0.3. 2. Yes, very good, Sheila Emmanuel Faisal. Why? Because first one not usable, it is network number. Last one cannot be used. So we got only 2 usable IP addresses and total 4 IP addresses or 4 hosts, right? So 2 usable. So whenever you want to calculate usable means you can use just -2, total -2. So 4 minus 2 is equal to 2. Easy, guys. So calculating maximum number of hosts. Now you guys will be saying, why did we need step number 1? This is just for your reference. Even you could do it from here as well. No need of this step number 1. Okay, yeah, let's do it again once more, Stanley. So let's do it with an other example, right? Let me open the example for you. Let's do it ourselves. So we have to calculate the number of hosts in this one, which is 192.168.0./29. So step number 1, what we have to do is identify the class. So which class is this one? This is class C. Now step number 2, this was just for reference, but the actual step number 2 is we have to identify the given mask. So what is the given mask here? /29. Now step number 3, very easy. What we have to do? We have to calculate number of hosts in this network, right? So what is the formula? 2 raised to power 32 minus given mask. While the given mask I have written with green, let me write here. So this is your given mask, this one, and then this is your given mask as well, which is 29. So very easy. Is equal to 2 raised to power 32 minus 29 is equal to 2 raised to power 32 minus 29 is 3, and 2 raised to power 3 is equal to 8. So we are having total 8 hosts in this network. So what will be those hosts? Let's start writing. The first host will be, yes, and 6 usable IPs. Very good. So 192 dot, so it will look like this. So it will be 192.168.0.0, because this is the network number. From here I can see this is the first one. Let's continue with 8 onwards. 192.168.0.1, 192.168.0.2, .3, .4, .5, .6, and .7. So total 8. Again, first one cannot be used, last one cannot be used. So these are the 6 IP addresses which will belong to this network. So clear guys on this one? Okay, so usable is always -2. Yes, this is okay. Jonathan says clear. Manzi, Inkesh, Maliha. If you understand this one, the next one will be easy for you. Right, so let's go through another example. So this is the example which I have solved as well, which I just showed solved with you. 192.168 given mask is this one. So 32 minus 29 is 2 raised to power 3, which is 8 and 6 usable. Very simple, yes. Okay, great. So another example 192.168.0.0. What is given mask here? 24, right? 2 raised to power 32 minus 24 is 2 raised to power 8, 256 minus 2, 256, 4 usable. But we need to care about this one. This is the actual number. Arabmai says, is 29 not classless? Yes, 29 is classless. But here, guys, is it classful or classless? Slash 24. Is it characterful or characterless? Yes, it is full. It is, yes, it is classful. Very good. So it means this is telling us that in the original classful subnet, there are 3 subnets in the world. That's all. Again, there are 3 subnets in the world. One is /24, other one is /16, other one is /8 for class C, class B, class A. So means 192.168.0.0. This is the original subnet. So original always has 256. We will see this one in next. I think maybe you don't understand now. Okay. Mr. Hacker says, apart from theoretical IP subnets, where do we get subnets practically? Mr. Hacker, I don't know your name, but we just discussed in detail. Please go through recording if you missed that part. But also there are some practical scenarios which are coming that where we use them as well. Okay, now another one, an example of class A. So 10.0.0. What is the given subnet mask? 30. So 30 means 2 raised to power h means host, 32 minus this 30. 32 minus 32 raised to, so it gives us total 4. And what will be those 4? So it will give us 4 hosts. The first host will have an IP address 10.0.0.0. I got it from here. Second one will be 10.0.0.1, but it is very important to put the subnet mask as well. This /30. 10.0.0.2, 10.0.0.3/30/30. Clear, guys? Then these are some exercises which I have prepared for you. You have to calculate the total number of hosts for this network, for this /27, for this /25 network. And then you also have to calculate for this /26, this 10.00/27, 99. So these are the exercises which you guys have to do yourself. And then you have to send me. Okay. The next part, can we move to the next part or any question about this one? 14 total and 14 usable. Very good. Okay, so let's move part number 6. Now, this is also the real math. So we are reaching to the next level of subnetting. We have to calculate the range of IP address. Let's say somebody told you in our previous example, let's go there. Here we just said that how many IP addresses we will get. We will get 10.0.0.0/20, 30. Then we will get the second IP address. Guys, please pay attention here. It is important. If you get the concept, math is easy. I have prepared these formulas for you guys in the easiest way. 1, 2, and 3, and slash, all is wrong. I was talking to you. 10.0.0.0/30. 10.0.0.1/30, 2/30, 3/30, and then this one is 10.0. Okay, now let's say somebody does what? They don't tell you everything. They don't tell you the original from where it came. What he does, he just picks up an IP address and he gives you this one. He says, guys, I have an IP address which is 10.0.0.1/30. Can you tell me what is the range of the network from where it belongs? Of course, what is the range from here? If we know the whole background, we can see that the range is from 10.0.0 up to 10.0.0.3. But here he did a trick with us. He picked up this IP address and he said, okay, if you are so expert, can you tell me what is the range? What is the original network from where this IP address has come through? You got the concept, guys? What is the question? The question here, somebody picked one IP address and he says, please tell me where does this IP address belong to? Yes, Sachin, you are right. You can see from here. But if you don't see all of this information, so how will you do all of that? How will you do the reverse engineering, right? This is what our next step is, next module is. So calculating the range of IP address means the range of IP address from where this network or this IP address belongs to originally. We have to go back now. How to do it? If you understand the concept, the mathematics is not so difficult. I have made it as easy as possible. Also, guys, when you do the subnetting with any other instructor, when you follow any book, any tutorial, you will always find a new method. So please don't get confused. There can be many methods to calculate. Even when we were discussing, I told you 10 methods of doing the things. But you have to find a way which is easiest for you. If you make whatever I am teaching you, if you make this one for your rest of the life, the things will be easy. So pick one method and keep it with you, but the concepts are same. So any teacher, any instructor will have the same concept. Only the calculation method might be different, right? So don't get worried if you see another method. That can be, even I have 10 methods whenever I teach subnetting. So the same lecture I remember when I did last time, I did it with another method. So minor changes as well. Okay, now the question will be like that. So in module number 6, I have made 7 modules total. So in module number 6, the questions would look like this one. They will say calculate the range of IP addresses from which we have picked this IP address. So he's saying, please tell me from where did I pick this IP address? This is like a trick, right? So same easy steps. First, step number 1, we have to identify the class and then we have to find the given mask because we will be using given mask. We already know what is given mask here, guys. It's there in this question as well. Yes, it is here in the question. So this is our given mask. Very easy. Now we have to calculate the network number and the broadcast number. So going back to our example, if you know the first IP and last IP means the network number, the first IP and the last IP of a subnet. If I tell you that this is your first IP 10.0.0/30 and this is your last IP 10.0.0.3/30, can you identify which will be the middle ones? Yes, it's very easy then. It will be .1 and .2, right? So the first IP we just discussed cannot be used and it is called as network number. The last IP cannot be used and it is called as broadcast number. So whenever we want to calculate the range, we will just try to find the first IP address from where this one belongs to. We will try to find the first IP and we will try to find the last IP. Then we will be able to know that from where does it belong, right? So step number 2, we have to calculate the network number. This is the last part of today, guys. So we will just take, I think, 15 minutes and then the guys who want to leave, who have data issues can leave and the remaining can continue with me to ask your questions one by one. I can unmute you guys so we can talk to each other one by one. So whoever will have questions, you guys can stay, the remaining can leave after this part. Tomorrow we will start again. We will revise. I will check your questions as well, your exercises which you guys would have been doing today. Even during the week you guys can do. So we usually hold these kind of sessions. Last week we did an MPLS session in detail. I think all of you have joined that one as well. Also we are, and then this subnetting you guys were asking from long time. We are also planning for BGP as well. So whoever wants to join BGP, please stay in the group or send message to admin that I want to join. So she will enter you as well. Also, there are full courses as well, which include all these topics for CCNA, for specialist, enterprise core as well, which are going on every month. So anybody who is interested, you guys can also join those ones as well. Okay, going back. So calculate network number. is this one. Ashiat says, okay, let's discuss that BGP MPLS after this. Let's do the calculation quickly, and then we can discuss the training courses as well. I'll explain. Okay, so calculate the network number, right? So we have to calculate the network number. How do we calculate? Very simple. It is also written here with the steps. We just have to do the AND operation of IP address and given subnet mask, right? AND operation, you already know what is the AND operation. If we AND 1 and 0, the answer is 0. It is just the multiplication. If you do 0 and 0, what is the answer? 0. If you do 1 and 1, answer is 1. So AND operation means multiplication operation, right? So we write the IP address in here. What is the IP address which they have given us? 192.168.0.1. So IP address is written in here. We convert it into the binary. So you can see why we learned the conversion from decimal to binary, because we are using it here. So you convert this number to binary. 192 in binary is 11000, all of that. 168 in binary is 10101000. 0 in binary is this, and then 1 in binary is. So we convert it to binary. Similarly, the subnet mask, the given mask which they have given us /30. Very easy. 30 means 8 bits, 8 bits, 8 bits, and then 24, 25, 26, 27, 28, 29, 30. So this is our /30 subnet mask, means 30 times 1. /30 means 30 times 1, and everything else is 0. So we have written our IP address, we have written our subnet mask. Then we do the AND operation. So we start from here. 1 and 1 is 1. 1 and 1 is 1. 0 and 0 is 0. 0 and 0. So similarly, we keep on doing AND operation until here. Then we convert this back to our decimal. So 1100, we need to use the calculator, or you can do the calculation as well yourself, which we just learned how to convert. But to just show you quickly, let me do the calculator. So for calculator, the number in binary, which is 11000000 is equal to 192. So that's why the number is 192. And then 1010 is 168, 0 is 0, and 0 is 0. So we found our network number. This is our network number, means our first IP address, right? So we write it here, the network number. Now let's calculate the last IP address. This is a little bit tricky. I think it would be challenging for you guys, but we will do many examples. Even tomorrow we can repeat them as well. But I want you guys to do yourself. So it is a little bit more math now. Then calculate the broadcast number. But this is the easiest way, guys, in the world. You would not find any other easiest way other than this one, unless you favor something. Okay, then calculate the broadcast number, means the last IP. This is the last IP address, right? We have been teaching this for years, and that's why we know which method is easy and which one is difficult for the students, and how you guys can get it easily. So calculate the broadcast number. We calculate the network number by doing the AND of IP and subnet mask, and we got our first IP, which is called as network number. Now what we will do, we will write our address network number, which we just got. So we will just write this network number here again. This one 192.1, this is actually 192.168.0.0, whatever we found just now. In that, we will just change all the host bits to ones. That's all, and then we will find our broadcast number as well. Again, we take our network number and change all the host bits, H bits, to ones, and then we will get our broadcast number, which is this one. We will do an example as well, don't worry. So how to find H? We just discussed already that H is equal to 32 minus given mask. This is the formula you have to remember. So 32 is the number, and then given mask was what? Given mask was 30. So 32 minus 30 is equal to 2. It means 2 bits are host bits. These 2 bits must be reverted to 1. So we reverted these 2 bits to 1, 1. Then we converted it to decimal again. So this one is equal to 192, this one is equal to 168, this one 0, and then this one becomes 3. So then we got our network number as well, which is 192.168.0.3. So this is the range. Now you already know how would this look like. It means how many hosts do we have? We have 4 hosts. What will be the first IP address? From here we can see the first one will be this one, 192.168.0.0. The second one will be what? Second one will be 192.168.0.1. Third one will be what? 192.168.0.2. Fourth will be 3. So that's how the range is from 0 to 3. Right? So let's do another example. Then you guys will understand. Yes, Francis, it will be shared, of course. It has been shared already in your groups and everywhere. Okay, so the question is that we have to find, this is another question, that from where does it come from? This IP address belongs to, of course, a range of IP addresses 1, 2, 3, 4, 5. So we just picked from here the second or third IP address. So how do we convert? How do we find the range? So how do we find the range? We find the first network number, and then the last we find the broadcast number. Then we will know which range does it belong to. The same method, right? So let's go step by step. Step number 1. First, we have to identify the class and given mask. Identify the class and given mask. So what is the class of this IP address, guys? From 192, you should be able to find. Admin, please share the PDF file in the chat window again. Some people are, yes, it's class C, right? And what is the given mask? 29, very good. Yeah, this is the given mask. So class is C and given mask is /29. Step number 1 done. Step number 2. Step number 2, we have to calculate the network number. So step number 2 is to calculate network number. So how do we calculate the network number? We just discussed. What we have to do is we have to IP, we have to write in the binary, and then we have to perform the AND operation with its given mask, means its subnet mask. Very easy. Right? So let's do it. Step number 2. So step number 2, this is our IP address 192.168. So let's convert this one 192.168.0.2. This is our IP address, right? So let me write this IP address on this side to make it easy for you guys to identify. So IP address is 192.168.0.2, and subnet mask is, given mask is how much? 29. So this is /29. So how do we write the IP address? 192. We need to convert. Guys, I saw some questions. People were asking that how did we get 192, how we convert? So you use the calculator or you use the method, which I have just shown you, how to convert the decimal number to binary. So 192 in decimal is equal to 110000 in binary. So this is how we convert. Let me write, which is 1100 and then 4 times 0 dot. Then 168 is how much? 168 in binary is 10. You guys can convert yourself as well. 10101 and 3 times 0. Then 0 in binary, 8 times 0. 1, 2, 3, 4, 5, 6, 7, and 8. And then let me delete this one and move it a little bit to the other side. So this one actually is 192.168.0.2. Okay, then the last digit 2 is how much? We already know 0 0, we will 0 0 0 0 1 0. So this is equal to this one. Is it clear, guys? How did we convert it last time? It's in your Windows, Uche. It's in your Windows calculator. This is what you have to do. But don't use the calculator initially. Do it yourself, the binary to decimal calculation, which we saw in step number 1 in previous lecture, in previous section, which we just did today. Okay. Now, let me convert this /29. This one is equal to means /29, guys, means what? Total bits are how many in IP address? 32, right? So out of 32, 29s are 1. This 29 means 29 times 1. So 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Then the remaining is all 0. You got it? So /29 means 29 times 1. Saurabh, you don't have to do, you just have to continue. Saurabh is saying it's a lot of calculations. You just have to write decimal into binary. And don't worry, it will not come into exam in so much theoretical. But we need to learn this one to calculate the range if you want to go further. And this is the easiest way. There is no other easy way. That's why subnetting is so difficult. And most of the people, they skip, they think they know, but actually they don't know. Okay, so now what we have to do is to do the AND operation. So we need to do AND between these two IP addresses, between these two addresses. So let's do AND. 1 and 1 will be how much? 1 and 1 is 1. 1 and 1 is 1. 0 and 0. 0, 0, 0, 0. Then again 1. 0, 1, 0. Yes, once you do it with your hand, you will find it. And this is the last step of today. We are not moving ahead. Tomorrow we will continue to the next step, right? And then again, we are doing the AND operation. 0 and 1, 0 and 1, all will be 0, because whenever you multiply something with 0, it's always 0. Then here again, 4 zeros. Fifth is 0. Actually, everything is 0 because 0 multiplied by 1. Then we convert this back to decimal. This is our network number. That's all. So 1100, we just discussed how much is this? This one is 192. This one we convert to binary. How much is this? This one we already know. This one is 168. You can use calculator or you can do it yourself. And then this 00 is 0 and then again 0. So 192.168.0.0 is our network number. Means this is the first IP address. Yes, Saurabh, you are right. And they will not give you this kind of question in detail, unless there will be calculator as well on words, CCNP, CCIE level. So network number, easy to calculate. We just did the calculation on, we just wrote our IP address and then we wrote our subnet mask. Then we just did the AND on both of them. Now the last portion is to calculate this was step number 2. Now the step number 3 is calculate the broadcast number. So step number 3, calculate broadcast number, means the last IP address of the range from where it belongs to, right? So what is the method? We have to change all host bits to change all H bits to 1. That's all. So how many H bits are there? I just told you what is the formula to calculate H. The formula to calculate H is equal to 32 minus given mask. So 32 minus given mask is how much? 29, right? This one, 29, it means is equal to 3. So it means 3 bits have to be changed in the original network number. So in this one, let me write again 192.168.0. Let me write the last one. 1, 2, 3, 4, 5, 6, 7, 8. So how many bits do we have to change? We have to change 3 bits to 1. So what will be the network number then? 192, sorry, broadcast number, 168.0. What is this number? 00000111, which is equal to, now we convert it back to our normal number. So this will be equal to 192.168.0.7. So it means what is our range now? Our range is, it starts from here. It starts from here and it ends in here. So the range is, sorry, the space is less, 192.168.0.0, and the last one is .7. So it is up to 192.168.0.7. So this is our range. This is the answer. So let's see on a clear page. I have done it for you already. So this is the one which we have done. Let's revise it. And then you tell me which point you are confused. Step number 1, identify the class and given subnet mask. Class is already, we know from the first digit is with class C, and the given mask is 29. That's all. Now, the actual thing, we have to calculate the network number. We have to calculate the broadcast number. To calculate the network number, we have just written our, this is our IP address, which is 192.168, and then this is the given mask, is equal to in binary. Then we do AND to both of them. So 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0. So finally it comes with this number. We convert it to decimal, which becomes 192.168. This is our first IP address or our network number. Then we put this network number in binary again and convert the H bits to 1. H is the formula to calculate the host bit, which is 32 minus given mask. Given mask is 29, so I input here. So 32 minus 29 is 3. It means 3 bits have to change. 3 bits means this bit, this one, and this one. So we change all 3 bits, we make them 1. Then this number 110, this becomes .7. So our first IP address is this one, last one is this one. Clear, guys? This is how we do it. So it means it gives us total 8 hosts. What is the first host number? First one will be 192. This is the same which I calculated with you, .0.0. Second will be what? 192.168.0.1, 192.168.0.2, 3, 4, 5, 6. Final will be 7. So total 8 IP addresses, and then 6 are usable. Okay, very good. Okay, welcome, Rafat. So let's do another example. Okay, you asked the question, Ezekiel. I'm still not getting how we get the 7. 7 is the digit we converted these bits 00 into 111. I think I'll unmute you, then you will tell me your exact question, guys. Whoever has a question, I'll unmute you once we finish. Let me go through one more example. Then you guys can ask me your exact question, which will clarify. But it will not happen unless you do, because subnetting is not something that somebody will give you lecture, which everybody expects, and then you will, everything will be in your mind. You have to spend time, you have to put some effort, only then you will get subnetting. So it is very simple to say I did not understand, but once you spend some time, then it will be easy for you to understand once you do with your own hand, right? Okay, so let's do another one. This one, /28. Now they have given us /28. IP address is this one. We have to calculate the range, right? Same thing. The given mask. Given mask is 28 and class is C. Okay. So we have to calculate the network number. we write our IP address, which is 192.168 in here, and then we write this /28 in here. Very simple, guys. Whatever is asked to you in the question, just write this 192.168 in binary here, and then this subnet mask in here. Then AND them. You will get your network number. So 1 and 1 is 1, 1 and 1, 0 and so AND operation. Finally, we get this one. This is our network number. Same thing again here. How much is given mask? 28. We have to calculate H and revert them to 1. But let's focus on class C first, so that the concept is clear in your mind. Then we will move to A after that. I'll give you an example on A as well. So 32 minus given mask, which is 28. So I pick 28 from here. It means 4. So it means 4 bits have to be changed. These 4 bits from here. And then we make 0 to 1, 0 to 1, 4 bits from rightmost 4 bits. Then you convert it to, so 11000000, all of this becomes 192.168.0.15. So this one is our first IP, this one is our last IP. And then the range is 0 to 15. So it means how many hosts total? It will give us 16 hosts. First and last cannot be used. It means 14 usable IP addresses. Right? Conrad says, I noticed that we always get the first IP. Practically, can we skip step number 2? Since looking at the IP address, we already know that the first IP would be, no, it can be different as well. Conrad? Yes, very good question. Conrad is saying that, guys, that's why I wanted to give you so many examples of the same kind so that your concept is clear. Conrad is saying that, can we skip all of that? Because we repeatedly see that it is always coming 192.168.0.0. So Conrad, I think I have made another example for you. This one. So if this IP address is not 0.1, let's say in that example, let me go back with you. This one. So Conrad, please follow. So if this IP address in the question is 192.0.5/30, then this is not gonna come this one. This one will be, the answer will be 192.168.0.4 because now it has moved to the next subnet. So don't think that it is always going to come this one. I gave you the examples which are all becoming this one so that you can differentiate between them. Clear on this one? But I'll unmute you. Let me finish the last example. Okay, then class A, which you guys are asking. So in class A, same thing, nothing will change. If you understand one, you understand everything. What is the class? Class is A. What is the given subnet mask? /30. Again, what will we do? Very simple. We write our IP address here. In binary, we write our subnet mask in here. In binary, we perform an AND operation on both of them. The answer will be this, and this, which becomes 10.0.0.0 in normal. So this is our first IP, which is our network number. Then what do? We just move this one again here. We write in binary again, and we find the value of H. H is 32 minus given 30. So 32, it means 2. So means 2 bits have to be changed. I think some of the guys, most of the guys who are still confused, they are confused on this H part. But let me unmute some of you so that you can ask the exact question which is in your mind. Yes, it is class A. Let me see, is it typing mistake? Oh, sorry, yeah, it is typing mistake, sorry. This one is class A, not C. Okay, so this one we have to change, it means we have to change 2 bits. So the rightmost 2 bits we have to change, we made them 1, 1, which gave us 3 in decimal. So the first IP is this one and last is this one. First IP 10.0.0, last is this one. It means it gives us 4 hosts. So did you guys notice something? Whenever we have /30, it does not matter whether it is which IP address, whether it is 172, whether it is whatever. So /30 always means it gives us 4 hosts, right? /31 always gives us 2 IP addresses. It means /29 will give us how many IP addresses? Always 8. /28 will always give us 16. So once you become expert, then you will start doing this one in your head. You don't have to write all of this, right? But first you have to do all of that. So then these are the examples, guys, which you have to do. These are the questions which you guys have to do. So 192.168.0.9/30. Here you will see, Conrad, that the answer will not be same as, you will not get the network number as 192.168.0.9. Sorry, 0.0. It will be something else. That's why I prepared this scenario for you. And then 192.168.0.1, 2.1/26. And then you guys have also to do for a class B, but class B, A, C does not matter when it is classless, because we already left our classes. So you guys have to do this calculation. Then the last scenario which we will do tomorrow, this is the practical one, and we will spend most of the time in this one. I think you guys are very clear up to the number of hosts. Then range, and this one we will do again. So here what are we studying tomorrow is I will give you a practical scenario like that. So for example, your company has given you 192.168. This one they are saying please implement into this network. So you have to decide now how many networks do you want, how many hosts do you want, right? So you have to make it 128 hosts this side, 128 this side. First you have to see total how many you are getting. You are getting 256. How many networks do you want? You want 2 networks. So it means you have to divide 256 into 2, which gives you 128 each. Then based on 128, you have to divide this one. So these are practical scenarios which we will study tomorrow in detail. This is the calculation. It's almost same. Here we just have to find the donated bit. So please study, please complete everything. Otherwise this will look a little bit more complex to you tomorrow if you don't do today's thing and if you just join the lecture again. So please revise everything, watch the recording at least 2-3 times, then everything will be in your head. Then the second practical scenario we will give you like that this is the class which has been given to you. So please implement this one and divide into 2 networks. So you will be dividing into 2 networks. How you do, we will study tomorrow. Then also this address range, this is practically how you do in your office environment. When I'm working here in MTN, we are also planning the IP addresses, everything here. I'm a consultant here for MTN Telecom. So here /24, which means now you already know /24 always gives us 256 IP addresses. So out of those 256, they are saying you have 62 computer here, 62 computer here, 62 here, and then this is also a network which will also need at least 2, but we will give it 64 as well. So you have to divide it into 4 parts. Yes, you have to go recording not only one time, even for the rest of your career as well. You can watch it again and again whenever you want to do as well. And then this is also a practical scenario we will do tomorrow. For point to point, we need 2 IP addresses. Here we need 2. So we have been given this subnet, which gives us 8 IP. So we have to divide 4 and 4 IP addresses into this one. So we'll do all these practical scenarios tomorrow. So first you do this until range today. So 1 to 6 sessions. Let me revise everything. Let me give you a summary and then I'll unmute you one by one so that you guys can ask the questions as well. So what we studied today, there were total 7 modules, total 7 topics which we have covered. We went through fundamentals, we went through IP address classes A, B, and C. We also went through decimal to binary and then back from binary to decimal conversion, maximum number of hosts in a subnet, how to calculate the range of IP addresses if you know one IP, how to find that this belongs to which range. And then tomorrow we are going to do the real world scenarios as well. So fundamentals, we studied what is IP, what is subnet mask, how does it work overall, what is IP address, what is network and host portion. Network portion stays permanent while host portion keeps on changing. And then we went through the examples of the classes in decimal numbers, but we have to do in binary usually. If we have a class of 100, we can divide into 2 classes of 50-50, or if we have a network of this range with 256 hosts, we can divide it into 128 each. Then we also went through practical that why we need subnetting for easy administration, for security, for improved performance as well. So this is an example. We divided this 256 into 5 subnets and assigned them. This is what we are going to do tomorrow. And we need to learn how to use donated bits. And 3 classes are there in total, class A, B, and C. From the first octet we can find. And if it is found with any other mask other than the default, then it is called as classless IP address. Then this is the exercise which you have to do from home. We learned how to convert decimal to binary with the simple math, which we learned in our elementary school as well. These are some examples. Then you have to do this exercise from home. These 8 questions you have to finish and send to me. Then binary to decimal conversion. We learned how to convert from binary to decimal. You have to remember this 1, 2, 4, 8, 16, all of that. And then you multiply and add them as well. Okay, and then you have to do these exercises from home again. Then calculating maximum number of hosts, module number 5 of subnetting. Very simple. We have to identify the class, given subnet mask, and the formula for number of hosts is 2 raised to power 32 minus given mask. So given is 30. We just placed here 32 minus 30 is 2 and then 4. It means we get 4 IP addresses in total, out of which 2 are usable because first and last is not usable. Another example, 192.168, we came to know that it gives us 8 IP addresses. 192.168/24 gives us 256. This is how, when you see the overall picture, you will come to know. Then /30 again gives us 4 IP addresses. This is the exercise which you guys have to do. And calculating the range of IP addresses as well, we have to calculate using the network number and using the broadcast number. So we have to write our IP address and the subnet mask and perform an AND operation. Then change the host bits to 1s, which gives us the last IP address. So this is how we calculate the range. Also, you guys can use the calculator, which I just showed you. So we'll see you tomorrow on the same time. Please do the practice. Please go through everything. Krishna says, I have a question. Okay, Krishna. Rafat Tanveer has a question. Let me unmute you. Rashid says, I have a question. Krishna. Yes, Krishna, I can hear you. Please speak. Mr. Who else has a question? Mr. Odi has a question. Mr. Odi, I can hear you.
Hello, good afternoon.
Good afternoon, sir. Please ask your question.
Okay. My question is on this second section of this subnetting.
Yes, sir.
I want to understand how to get the network address and then how to categorize it.
You mean getting the range? This one, if you see my screen?
Yes.
Okay, step number 2 or step number 3?
Step 1.
Step 1 is to identify the given mask, that's all. So step 1, already they have told us in the question. This question, if you see, they are saying that please find the range for this one. So we can see from here it is 192.168, which means that which class is this one? 192 says this is class C. And then given mask is already there, which is also /30. So we have not done anything. We just have identified. That's why I wanted to show you how to identify from the question. You don't have to do any calculations.
I'm more confused on the step 2 and step 3.
Okay, step number 2, what we have done, you stay with me. Yeah. Step 2, what we have done, we have written this 192, whatever is given in question. They gave us 192.168, right? So I just wrote 192.168 here in binary format. Clear until here? Mr. Roddy? Is it clear? I just wrote in binary, right? And then in the next step, what I did, I just wrote, I took this /30 from here. I also wrote it in binary in here. And then we did the AND operation on both of them, right? So 1 and 0, the answer is equal to 0. 0 multiplied by 0, answer. So we just multiplied them with each other. Then we came with this one. Clear, Mr. Roddy? You're seeing the screen? Okay. Okay. And then this one is 192.168.0.0. This is how I got it. So I didn't do much. I just wrote the IP address. I just wrote the mask. That's all. And then I multiplied by them. 0 multiplied by 0, 1 multiplied by, so I multiplied by them. And the answer came as this one, 192.168.0.1. You do it yourself, watch the recording again, then you will find it.
The mask address is now in hexadecimal, right?
In binary.
Okay, in binary.
Yeah, 30. You can also see 30 means 30 times 1.
Okay.
So 8, 8, 8, and then 30. So 2 we have left. So 30 times 1. So this means /30 means this one, and this one is equal. So you just need to learn how to convert the decimal to binary. I think you are confused on that step. So first you go back, go to step number 1, which we studied, how to convert 192 into this one. Once you are clear on that one, you will be easy here. So I have just converted this into binary. I wrote here. So this whole thing, this brown color means 192.168. This whole green thing /30 means this one. This is how we write. So you keep on doing it for all the examples one by one, again, watch the recording again, then you will be able to. So don't worry if it looks complex to you.
Yeah.
Okay, welcome, sir. So thank you guys. Thank you for joining. Please join tomorrow, same time. Please don't be late and don't wait for recording as well. Okay, welcome everyone. Thank you for joining day 2 of IP subnetting. Yesterday we discussed in detail the IP subnetting. Total there are 7 topics which we have covered in this course. This is a short course like I explained yesterday, and it's free for everyone. Today is the second and last part. Yesterday was the first part in which we studied about fundamentals of IP subnetting, IP address classes, the conversion from decimal to binary, and then back from binary to decimal. I hope all of you had joined yesterday as well, but I can see there are few guys who are new today. So yesterday's session was recorded. You guys can get the recording of yesterday's session from admin, and they will also share in your WhatsApp group as well from where you guys have joined. My name is Arman. I will be the instructor of today's class as well. So yesterday we have studied already the fundamentals of IP subnetting, IP address classes A, B, and C. We discussed why we need IP subnetting at all. Then we discussed how to convert from a decimal number to binary and then back from binary to decimal as well. How to know that how many maximum number of hosts are there in a subnet. And then how to calculate the range if we know the IP address and the subnet mask. So if we are given. And today we will revise this number 6 and we will go with number 7 as well. But let me give you a review of from 1 to 5 what we discussed yesterday. Right? So I hope everybody can hear me loud and clear. Okay, first of all, IP subnetting. Yesterday we discussed why do we need subnetting at all. So we need subnetting so that we can take one network and divide the number of hosts into multiple small networks. It has 2 parts. Each IP address has 2 parts, IP address and the subnet mask. IP address tells us what is the number of the host, and subnet mask tells us where does it belong to. We discussed with the help of some examples as well, this roll number example of our training courses which are going on. So we discussed that some parts are fixed and some are variable like a roll number and class. So classroom number tells us where does this IP address this person belongs to, and then the number 1, 2, 3, 4, 5, this one tells us what is the number of the student. Similarly for all other classes. This is how we do the subnetting as well. So it is 100% same concept. Right? So after that, we discussed how to divide a big network into 2 small networks and why do we need to do all of this at all. Today we are going to do the same thing and we will learn how to divide this whole network. For example, if we are given 10.0.0/24, this one gives us 256 hosts because we already know now how to calculate number of hosts, which is 2 raised to power 32 minus mask. Mask is 24, so this is 2 raised to power 8, means it gives us 256 hosts. I hope it's very easy for you guys now after yesterday. So these 256 hosts we need to divide now into 5 networks. So out of these 256, we give some of the hosts, around 30 to this one, and then around 30 to this network number 2, 30 to this one, 2 to this network, because between two routers, this is also a network. So total there are 5 networks. We have divided 1, 2, 3, 4, and 5. So this is how we do the subnetting, and this is why we need the subnetting, because we cannot keep on assigning this one. It is shown in the screen as well. How do we do this one? So then we studied in section number 2 about IP address classes, that there are total 3 classes, class A, class B, and class C. There are default subnet mask, and we can identify the classes from their first octet, from the first number. If it is between 1 to 126, it is class A. If it is between 128 to 191, it is B. From 192 to 223, it is class C, and it should be found with the default subnet mask. If it is not found with that, it means it is classless IP address. Then I gave you some exercises as well. Today also, I will give you a home assignment which you guys can complete during this week, and you can submit it online as well. So this is the, okay, so we studied about IP address classes, then decimal to binary conversion, like our old elementary school. If somebody has not joined yesterday's lecture, please go through the recording. You will find it very easy with the easiest method, that how to solve this one. Then we also went through binary to decimal conversion. We have to write these values of 2 raised to power 0, 1, 2, 3, and then multiply, and finally make them addition. It gives us in decimal. We also did these examples. Then we also came to know how to calculate maximum number of hosts. So we just have to write the 3 steps. Step number 1, we have to identify the class. Step 2, we have to identify the given mask, which is already there in the question. On the top you can see. And then how to calculate total number of hosts, 2 raised to power h, which is equal to 32 minus given mask. H is always equal to 32 minus given mask. Given mask is already there, which is 30. So we copy 30 from there. 32 minus 32 raised to power 2, 4 is the answer. But first and last IP address is non-usable always. So we get 2 usable host IPs, but total there are 4 IPs. First and last cannot be used. So we learned with these examples how to do these ones. And then there was an exercise as well. Then we came to topic number 6, which we can revise today as well. So who has understood 100% the calculation of range yesterday? And do you have any question from yesterday, what we studied, how to calculate the range? So it was 3 easy steps, although it's 4, but first step you can skip as well. So what you have to do, whatever is given to you in the question. So in question they tell us, please calculate the range of this IP address. What we have to do, we have to simply write this subnet mask, this IP address or network number in binary in here, and then we have to write this /30 in here as well. /30 means 30 times 1. Don't convert this to binary, right? And then do the AND of them, means multiply. 1 multiplied by 0, 0 multiplied by 0, 1 by 0, 0 by 0. So this is the answer. It means this is your first IP address, which is 192. Then I converted it to decimal, 192.168.0.0, right? Once we found it, second step is to write it again and find the value of h. We just discussed value of h is equal to 32 minus given mask always, right? Given mask is 30, put 30 here. So 32 minus 30 is 2. It means 2 bits have to be changed in the network number. So we make all of these bits as 1. So 1 and 1, 1 and 1. 2 bits, 1 and 1. So this is our last IP address. That's all. We found it already. 192.168 is our first IP. 0.0 192.168.0.3 is our last IP address. So any questions in here, guys? What we studied yesterday? Then I can also show you some more examples. Let's calculate together so that you will understand it more. Yes, it's same. Tanashi, it's same. Yes, we will go through the example which are written there already, Conrad, instead of just because otherwise everybody will start saying, please do this example, this example. So let's follow what is here and then we can do whichever examples you want to do. But the rules don't change. Rules are 100% same. So we will do class A, class B, C, don't worry. We will do all of them one by one. But first let's understand what is here. Okay, it looks like, okay, people are suggesting their own subnets to calculate, no problem. Let's do the examples for which we have already prepared the private. Thank you very much for this. Okay, very good. Thank you, Samson. Thank you. Welcome. Can try this example. Okay, guys, so it looks like no questions in here. So let's go to the next examples. Let's do all the examples and then we can do the exact ones which you guys want to do as well, right? So no, if there is no subnet, we cannot calculate. So the question from someone is, if there is no subnet, what to do? If there is no given subnet, we can't do anything. Okay, so let's do this one. Let's do step by step. Please try to follow this one. 192.168.0.2. We have to calculate the range of IP addresses. Very simple. What do we have to do? We have to write this one in binary and we have to write this one in binary and then multiply them bit by bit. So let's write it in binary, right? So 192.168, I already know that 192 is always 1100. You guys can convert following the method which we just did yesterday. Convert it to the binary. So 192 in binary is, this is actually 192. So 192 in binary is this, and then 168 in binary is 10101. 000. You guys can use calculator or you can calculate yourself. And then this is 168. Then the third one is 0. So let's write 000. It has to always be 8 times. And then 2, we already know 2 is 10. So 0000 0010. This is 2. Clear until here, guys? So we just have to write given IP address in binary. Now we have to write this given subnet mask as well in binary, which is /29. /29 means 29 times 1. So let's write it 29 times. This is the given mask. So let's write it 29 times. This will be given to you in question. Okay, thank you, Jenny. So let's write it 29 times. 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So all 29 times 1. And then remaining 2 should be what? Should be 0. 0.0, right? Now what we have to do? We just have to multiply them bit by bit. So 0 multiplied by 0, what is the answer? 0. 1 multiplied by 1, answer A. 1 multiplied by 0, answer is 0. 0, 0. So all whatever we multiply by bit, everything needs to be zeros because anything multiplied by 0 is always 0. So 0, 0, 0, 0, 0, 0, 4 times 0 again dot. And here we might find some ones as well. So it will be 0 multiplied by 1 is 0, 0, 0, 1, 0, 1, 0, 1, right? Again 0, 0, 0, 0, 0, 0, 1, 1. So this is our first IP address, which is called as network number as well, right? So this is our first IP address. Let's convert it into our normal number. So we already know 11000 in normal numbers is what? Is 192 dot. This one in normal number is 168. 0 is 0 dot 0. So this is our network number. This is our first one, right? Now the second step, what we have to do is the second step, we have to calculate third step actually, if we follow our documentation, but this is the second. So what we have to do, we have to calculate the last number. So what did we do? I told you already that we have to write this number again. And first we have to calculate the value of H. H is equal to 32 minus given subnet mask. So what is the value of H here, guys? Can somebody tell me? Please write there. What is the value of H here? 3. Anwar, Kishore, Toby. Okay, people are clear. Somebody wrote 29. 29 is the mask, but value of H is 3. 32 minus 29. This 29, I just wrote it here. So is equal to 3. It means how many bits should be changed in this one? 3 bits. We make them 1. That's all. That will be our last IP address. So let me write that one first. 11000000 dot 10101000 dot 8 times 0 dot 8 times zeros again, right? So what we have to do here, we have to change these 3 bits because the value of H is 3. 3 means we have to change 3 bits in here. We make them 1. So 1, 1, 1, and remaining everything is same. So remaining things are to be the same. Let me write here in white color so that I'm giving them different colors so that you guys can understand easily. Right? Everything else is same. 0011. This is our network number, right? This is our network number. We can convert it into our normal number. This is 192, this is 168, this is 0, and 111 is what? Is 7. So what is our range, guys? So what is our final range? The range is, the range of IP addresses is 0 to 7. Yes, you are right. So we have to write this one, which is 192.168.0.0 up to where? Up to this number. So this is 192.168.0.7. This is the range of IP addresses from where this IP was belonging to. Clear, guys? So it means the first IP address, let's write now. The first IP address will be what? If we find from this range, the first IP address will be 192.168.0.0, which is network number, which is unusable. 192.168.0.1, 0.2, 0.3, up to 0.6, 0.7, 192.168.0.7, right? This is 0.7. These are the 8 IP addresses, which was one of them. So it means 192.168 belonged to where? It was belonging to this range, and it was the third IP address of this range. You can see .0, .1, .2. So .0, .2 was the third IP address from this range. Clear on this one, guys? So let's do another example, right? Now you guys have to tell me step by step. Yes, Sheila, the range starts from the first one, but usable IPs are the ones which we can understand, which we can assign to the hosts. So let's do it again. One more, let me see the colors. So it was yellow on the top and then greens as well, and then everything else white. Okay, so let me start with the same colors. So step number one, what we have to do, step number one is we have to write this in binary. Step number two, 29 has to be written in binary as well, and then we multiply them bit by bit. Clear until here, guys? That what we have to do. Sorry, it's same which we have done already. So what we are going to do is now is 0.1/28. So we don't have to do this one. We have to do 192.168.0.1/28. 29 we have already done, right? So let's solve this one, the range of this one. So again, the same thing. What we have to do, so first we have to write this in binary, then write this in binary, and that's all. So it's easy. Let's do it. 192.168 we already know. You just saw it, right? In the binary format, what does it become? So it becomes 1100, then 4 zeros dot 10101,000 dot, because this is 192, this is 168 in binary, and then 000, 8 times zeros, this is 0 dot 1 is 01, so 4 zeros and then 1. Then /28, guys, how many ones should be there in /28? Can somebody tell me how many ones should be there in 28? Yes, 28 times 1. Do not convert 28 into binary, because if you convert, that is something else. We are not doing that. So /28 means 28 times 1. So let's write it 28 times 1. So 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24 dot 25, 26, 27, 28. What else? The remaining should all be zeros. So 28 times 1. Yes, Honesty, very good. You wrote it in detail. So what is our final answer? Now we need to multiply them bit by bit, right? So 1 multiplied by 0, what is the answer? 0. 0 by 0, 0, 0, 0, 0, 8 times all zeros. Here again we can see they're all zeros. So because if one of the multiplication factor is 0, it means answer will be 0 as well. And here what we are gonna get? We are gonna get the same thing when we multiply them, because they are all ones. And then 0, 0, 0. So we convert it to the decimal. Simply, the decimal is 192.168.0.0. So this is our first IP address. We found one thing. Now again, the same thing what we have to do. We have to convert the 3 bits from here, not 3 bits, sorry. We have to find the value of H, and then those H bits need to be, number of H bits need to be converted. So what is the value of H here, guys? Can somebody tell me what is the value of H? Because H is equal to 32. Very good. Samson, Perrin, Francis, Kishore, Kareem, Robert, Boris said. Very good. Yes. 32 minus given subnet mask. So 32 minus, what is the given subnet mask? It is 28. So we write 28 here. 28, which gives us 4. So it means 4 bits have to be changed to 1 in here. So this will be 1, this will be 1, 1 and 1. So once you become expert, even you can see from here that 4 times 1 is how much? 4 times 1 is 15. So our range is from 0 to 15. But let's calculate it for you guys. So we write it here again. And then we change the 4 bits to, so we write here again 1, 1, 0, 0, 0, 0, 0, 0 dot 1, 0, 1, 0, 1, 0, 0, then 0, 0, 8 times 0 dot 0, 0, 0, 0, but these 4 bits are 1, 2, 3, 4. Why? Because the value of H is 4. So it means 4 bits have to be changed to 1 from the network number. So we convert it into our normal number. Normal number will be what? 192 This one is equal to 168. This is 0. And this one is equal to how much? 15. So this is our last IP address, right? This was our first IP address. So we now know already that what is our last and what is our first IP address. So the range is what? The range is equal to 192.168.0.0. This is first, and the last IP address is 192.168.0.15. So it means it gives us how many IP addresses, guys? Somebody said, how do we got 15? So let me find it, went on top. Muhammad Shahid Ali, we got 15 because 111, we convert this number. So this number got converted actually into binary, into decimal. So this number in decimal is equal to 15. This is how we got 15. Let me see who is saying. Valid IPs are 14, 14 usable, very good, yes. So it gives us 16 total IP addresses. And then we have, Sterling says, but let me not mute everyone, guys. So let me only mute 1 or 2 persons so that any doubt in your mind you can clarify. Yes, Sterling, please speak up.
Okay, good evening.
Good evening, good evening. What's the question?
Please, I wanted to ask a question.
Sure,
If
sure.
the last four numbers where we turn 111 were to be 111, like when, okay, let me use my mouse. Okay, I'm not sharing my screen. Where you have
No,
1100.
Yeah, I know. Yes, here we have 1100, right? This one?
Yes, yes.
Okay.
If it were to be 111, what happens? Are we still going to change it over to 000, or we'll leave it like that?
It will never be 1. Very good question. So the question of gift is that if these numbers are already 1, then what to do? Right, gift? This is your question. That if this number is already 111 here, then what do we do? So we don't do anything.
Yes.
The answer to the question is then we don't change. But this number will never be 1. Why? Because these are host bits. So the rightmost bits will always be zeros and leftmost bits will always be 1. Because in every subnet mask you can see /28 means 28 times 1 and remaining zeros. /29 means 29 times 1 and remaining zeros on the right side. /24 means 24 1. So it means whenever somebody will multiply with these zeros, the rightmost things are always going to be 0. Clear?
Okay, so are you saying that we can't have /32 bits?
Yes, that's why 32 is an exceptional. I was coming to that point because with 32, if it is already all ones, we don't do anything. So that's why with 32, we don't get the range. So 32 range will be from 1 to 168.1.1, 1.1. So only one IP address, which is the network number, which is the, so there is no usable IP in that.
Okay, thank you.
Okay, but welcome. But let me not unmute, guys, everyone, because then it will be, we will derail the session time as well. But I will unmute just like yesterday. So maybe I can unmute 1 or 2 people, whoever have questions. Please ask relevant questions, just like ask very relevant. We need to have mind. Okay, so do another example. I think you guys are very on 168. So whenever you are doing subnetting, so start with 168. So that becomes easy. Class B, class A is the easiest. Some people are still saying like saying, okay, can anyone or is it bring with everyone? So let's do our examples first and then we talk in detail. Just like yesterday, even I can spend more than 1 hour with you guys. That will be fine. So please keep noting down your question or write in the chat window in a short format so that I can read quickly and I can answer to the question quickly as well. Agreed, guys? Okay, so let's do. So I can see some people are saying, let's move to some other example. So let's move to class A or class B, right? Let me give you something simple. So let's not go with this one. right? So let's try to solve something like 10.0. It is already there in your literature as well, ./30. So let's convert this one. Either 111 or 11, everything will be same. So let's work on this one, because we also have to do the practical scenario as well after this. Okay, so step number 1, again, what do we have to do? Step number 1, same thing, there is no big difference. So I just want to clarify your doubt. So step number 1, we have to write this one in binary. Step number 2, we have to write number 30, which is given mask, in binary as well, and multiply them by bit. So this is very easy. Let me convert. So 10.0.0.1. So 10 in binary numbers, I already know, 0, 0, 0, 0. And then 10 in binary is 1, 0, 1, 0. So dot 0, 0, 0, 0, 8 times. So I converted it. Dot 0, 0, 0, 0, 8 times zeros again. Dot 1 is 0, 0, 0, 0, 0, 0, 1. And then the subnet mask, what we have to do, /30 means how many times 30? How many times 1? 30 times 1. So 1, 2, 3, 4, 5, 6, 7, 8, dot 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and then remaining 2 zeros, right? So multiply them together. 1 multiplied by 0 is 0. 0 multiplied by 0 is 0. Of course, it is going to be all zeros. Dot. Again, 0, 0. So everything is going to be, let me write in sequence quickly. This one and this one is also going to be 8 zeros, because anything multiplied by 0 is 0. And then in here, we are gonna 0 by 1 is 0, 0, 0, 0, 1, 0, 1, 0. So this is our first IP. This is 10, 0, 0, 0. So first IP is 10.0.0.0. This is our first IP, or this is our network number. Now again, the same thing, what we have to do. What is the value of H here, guys? What is the value of H? Can somebody tell me? 2. Very good. Now you guys are getting it. So what do we have? Value of H is always 32 minus given mask, or minus subnet mask. So we put 30 in here, which gives us H is equal to 32 minus 30, which gives us 2. So it means 2 bits have to be changed to 1 in here. So let me write it here again. 0, 0, 0, 0, 1, 0, 1, 0, dot 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. We don't touch anything else other than the last 2 bits. Only these 2 last bits. So 0, 0, 0, 0, 0, 0, and then 1 and 1. Why? Because the value of H is equal to 2. So 2 means 2 bits have to be changed. So now convert this one to normal number, which becomes 10.0.0. What is this? 3. Right? So this is our last IP address. Now what is our range? Again, the range is equal to from first IP 10.0.0.0 up to the last IP 10.0.0.3. So how many IP addresses is it giving us, guys? How many IP addresses? 4, yes, and 2 are usable out of that. Also, you can calculate using your formula as well. What was the formula to calculate the number of hosts? Total number of IP addresses, 2 raised to, does somebody remember what is the formula to calculate if we don't follow this whole process? Yes, very good, Mr. Hacker. 32 minus given mask. 2 raised to power H, which is equal to 2 raised to power 32 minus given mask, which is equal to 2 raised to power 32 minus 30 is equal to 2 raised to power 2, which gives us 4. So without doing all of this, if we just want to know how many are there, then we can use these 3 lines only. But if we want to know that what are those IP addresses, then we have to do this whole process. Now you know these two steps, the difference. This one tells us what are those IP addresses. First IP, second IP, third IP, fourth IP. But if we want to know only that how many IP addresses are there, very simple. 2 raised to power 32 minus whatever number they have given you. That's all. So let's do some more example in here, because if you understand range, calculating the range is the key to subnetting. Right? So I just got from someone. Now I want to give you an experience, because until now what was happening, all of them were zeros, because I wanted to give you easy examples, right? So let's move to some next example, next level example, right? Again, this is not the question. So question is now, let's do something other than third octet/shouldn't be 0 now. 192, and it shouldn't be the first subnet. 168.10.44/29. So if I ask you how many IP addresses will it give us, guys, totally? That is very easy. 2 steps only. 32 minus 29, 3. 2 raised to power 3 is 8. Yes. Now you guys know already, right? Because from 29 you can find it very easily that how many IP addresses will it give us. But we need to know which IP addresses are those. So we need to do the whole calculation of range as well. So let's do it. Very easy. Again, we have to write in binary format, and then we have to write our mask as well in ones format in binary, and then we multiply them. We get first IP. Then we calculate the value of H, which is 3. 32 minus 29, and then we change 3 bits. It gives us the last IP. Very easy. So let's do it. So first we have to write 192.168 in that format. Now I am not going to, because once we multiply 192.168 is always same, right? So you can directly write 192, because you know 192 is gonna give you exactly again 192. But for your easiness, let me write it. So 192, we already know what is that. 1100, and then 4 times zeros. This is 192 in binary. Yesterday we already studied how to convert this to binary. Then 168 in binary is what? 10101, and then 3 zeros. We also know this one. Then 10 in binary is what? So now we have to do some calculations as well, but I already know you can do the calculation. This one in binary is 0000, and then 1010, and then 44 in binary is how much? So 44 in binary is 00. You guys can use your calculator as well. 0010, and then 1100. Please check if it is convert as well or not, if it is correct or not, right? So this one is 10, and this one is 44, right? Idris says, I don't know how to calculate that. Idris, please go through the yesterday's lecture. We studied this in detail. Even today I have explained as well before starting the session. You can go through the part number 2, part number 3. You will find that how to convert binary to decimal and back from decimal to binary. But you can use calculator as well. For CCNA, you might have to do in exam. For CCNP, for specialists, for CCIE, they allow you the calculator as well. Okay, so we convert it, and then we have to write the subnet mask. So 29 in binary, it means /29 subnet mask in binary means 29 times 1. So 1, 2, 3, 4, 5, 6, 7, 8, all ones. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. All remaining 3 are zeros, right? Then we calculate our first IP address. So we already know, let's do from the left side. So 1 multiplied by 1, 1 multiplied by 1. So this one, of course, is gonna give us the same number again, 11000000 dot. Also in here, we are gonna get the same 101 because I am just multiplying them, right? And then 10 is also gonna be the same 00001010 dot. Now the question comes here. So what are we going to get in here? it will be 0 by 1, 0, 0 by 1, 0, 1 by 1, 1. And then 0 by 1 is 0. And then 1, 0, 0, 0. So we convert this into binary. This is our first IP address. So it will become 192.168.10.40. So here it did not come as 1 or as 0. This last one, in all our previous examples, this was coming up as 0 or something. So this is our first IP address. Then in that first IP address, we calculate the value of H. So what is the value of H here, guys? 3, very good. H is equal to 32 minus given mask. Given mask is 29. So 32 minus 29 gives us 3. So value of H is equal to 3. It means we have to change 3 bits from this first IP, which will give us the last IP. So we make it 1, 1, 1, these ones, right? So let me write it here. Same thing, 1, 1, 0, 0, 0, 0, 0, 0, dot 1, 0, 1, 0, 1, 0, 0, 0, dot 4 zeros, 1, 0, 1, 0, dot 0, 0, 1, 0, 1. And then these 3 digits have to become, these 3 digits have to become ones. So because of the value of H is equal to 3, so 3 bits became 1, right? This is our last IP address. So let's convert it. Then it will become also 192.168.10. What is this number in decimal? It becomes 47. So what is our range now? Because this is our last IP. So our range is equal to 192.168.10.40 up to 47. So 192.168.10.47. This is our range. This is our answer. Right? From 40 to 47 means 8 IP addresses. Dot 40 cannot be used, dot 47 cannot be used, 41, 42, 43, 44, 45, 46. 6 IP addresses are usable. Clear on this one, guys? I saw somebody was saying to do class B as well. So let's do one class B as well. Then we move to the next step. It's all same, whether you do class A, B, C, whatever you do, it's all same. Don't worry. Okay, so let's do the last one before we move to the next step. So the next is 172.16.5.34/20. Let's make a little bit big. So /26. Again, same steps. Now it is boring for you guys, I guess. We just write it in binary. Even instead of writing in binary, you can just write, because up to 26 bits, nothing is gonna change. So the answer is going to be 172.16.5, and then 34 is gonna change. Now we already know from our experience, but let's do it for you guys. So 172 in binary, let me try to know that. Let me find some other example where I have 172. So I can copy from there instead of just calculating again. No, it's not there. So let's use calculator, right? So this is how you guys can calculate as well using the calculator. Also, you can use yesterday's method in which we studied how to do the conversion from decimal to binary. So 172 in decimal is equal to this one in binary. Okay, very good. I can see some people have converted. Boris said Okan, Ovovo, very good. It means you are getting. So let's write it. 1 0 1 0 1 1 0 0. What is 16, guys? Can somebody convert for me? Go to decimal and then type 16, and then we come to know this one straightforward. So because left side we have to put 3 0 0 0 0 to make it 8 bits total. So 0, 0, 0, 1, 0, 0, 0, 0. Dot 5 is how much? So let's convert, oh sorry, let's convert 5 as well. Go to decimal. 5 in binary is 4 0 0 0 0 and then 0 1 0 1, right? And then this 34, can somebody convert as well? Thank you. I can see Trevor, Yoko, very many people are converting. So go to decimal, click on 34, click on binary, you will find this as well. But it's good idea, the people who couldn't join yesterday or who joined late, they can also see here. So 2 zeros, 1 0, and then 0 0 1 0, right? So this is 172. This is 172.16.5.34 in binary. So we just converted them. Now let's write our subnet mask. Very easy, no need of any conversion. 26 means /26 means 26 times 1. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. Then remaining all 1 2 3 4 5 6 zeros. Clear on this one, guys? You can see there is no difference between class A, B, and C. It is just the same method. If your method is correct, you don't have to worry about classes. But there are many methods which, you know, they tell you something else for class A addresses, they tell you another method for class B, then it becomes very complex. So better you follow this method of subnetting, which I told you yesterday and today. Then all your concepts are good for the rest of your life. So you don't have to worry about anything else. So just do the exercises, follow this recording, keep this recording with you. It will stay forever as well. Whenever you have an interview, anything, you guys can just watch this recording. You will understand everything. But I also want to have another session with you guys in which I will explain you high level that why are we doing all of this. I will not go into mathematics. I will just tell you high level that, okay, how to do the subnetting, why we need. For example, if we have a /24, for example, if we have this /26, why are we doing this and how is it being done? Just, you know, on the logical level. Or maybe today after the session, I can spend 10 minutes to explain that as well. That will give you the overall understanding, because here we are doing mathematics. But once you are working as a network engineer, you don't have to do mathematics. You can use your calculators as well. So, but your logic should be correct. Okay, so let's multiply them. Very easy. So what will be there? It will be same thing, 1 0 1 0 1 1 0 0 dot. The same thing, 0 multiplied by 1 will be 0 0 0 1 0 0 0 dot. Again multiplied by 1 is 0 multiplied by 1 is 0 0 0 1 0 1 dot. Here we have to do something. With 34, what is the answer? So we have to find. So 0 multiplied by 1 is 0, 0 by 1 is 0, 1 by 0 is also 0. So 4 zeros, so 4 and 4. You can also write like that. So 4 zeros and then 0, 0, 0, 0. So the answer which came through is, let's convert it into binary. So the answer is 172.16.5.0. This is your first IP address, right? So let's calculate our H value and find our last IP address as well. Let's calculate our H value. What is the value of H here, guys? Can somebody tell me? No, not 64. Okay, Conrad, yes. 6. Sheila, Philippus, Jonathan, or let's say Shahid Ali. Okay, very good. Boris said H is equal to 32 minus subnet mask, or given subnet mask is equal to 32 minus 26. We have to put here 26 is equal to right. So it means the first 6 bytes from here, from this network number, have to be converted to 1. So very simple, just write this one again, but convert the 6 bytes to 1s. 10101100 dot 000100. Even no need to write, you know, now you are expert, you can know that this is already 172.16.5. Just write the last number. Give me a second. Let me reset the pen. Okay, so here we have to write dot 0000 4 times. Then this one 0101 dot 00. Now here we have to write 6 times 1. 1, 2, 3, 4, 5, 6. Why? Because the value of H was 6. So we had to convert 6 bits to this one. So let's convert this one now back to our decimal. This one is 172. This one is 16. This one is again same 5. And then this one, I can see many people have converted. Yes, this one in decimal becomes 63. Because from the IP, we can also see 2 raised to power 6 is 64. So I can know it will be 63. But you have to calculate. You don't have to guess until you are expert, right? So this is our last IP address of the range. So what is the range? The range is equal to first IP 172, which is this one, dot 16.5.0, and last IP address is what? 172.16.5.63. This is our range. So it gives us 64 IP addresses. Also, we can know 2 raised to power 6 is equal to 64. So even we could have known this one from the start without doing the calculation. So clear, guys? This is our range. This is our answer. Now I want you guys to help me something. We did so many examples and you guys were saying that 192.168 is very easy, right? So I want you to work with me now. Let me tell you an IP address and I want you to guess. Just give it a rough guess. If you cannot, it's fine, because I know this is the first time we are doing, but I want to clarify something with you. So if I write the IP address is 192, or let's make it 10, it will be more easy. So let me write 10.0.0.1/30. So what is the range of this one? And will it make any difference if I give you this IP address as well, /30? Will they give us the same range or different range? And if I give you 10.0.0.5/30, okay, all of them are same, you guys are saying, right? How about the third IP address? Is it same or different? Yes, that one is different. This is what I want to clarify with you. So it means that both of them, they belong to the same network. But this one belongs to a different network. The first two, both of them, if you calculate the range, this is why we calculate the range, so that we can know who belongs to where. The range of this one, both of them is from 10.0.0./30. This is the network, and the range is from 10.0.0.0 up to 10.0.0.3. But as soon as you move after that IP address, it means you have moved into a new subnet. So the new subnet is 10.0.0.4/30. So these two are very different networks. It means if you have a laptop, now let's go to practical. If you have a laptop and you have another laptop, if you assign them an IP address 192.168.0.1/30 and you assign 192.168.0.3/30 or 0/2/0.2/30, it means you can connect them together using a simple switch. So here you can just buy a switch, a layer 2 device, and they will be able to communicate with each other. But if you have a laptop which has an IP address 192.168.0.5/30, Now this laptop cannot be connected in here. If you connect, it will not work because switch is a layer 2 device. And now these are two different networks. It cannot work between two different networks. So what we have to do is we have to go buy a router, right? So we have to buy a router. We have to place the router in between and then connect one point here and the other point here. So this side is one network and this side, all of these IP addresses and router port is one network. So now you can see practically why we need subnetting and why is it so important. Because if you don't know subnetting, you will be doing all of this configuration wrong. When you will be planning, when you will be working in your job, if you don't know subnetting, you don't know routers and switches as well. Clear on this point, guys? So this is how I want you to sit and think easily. Once you know the subnetting, once you are good with mathematics and everything, then forget about mathematics, forget about calculating, just think logically that which subnet belongs to where and why do we need the subnet and all of that. Then I can have a session with you guys as well. I can ask you some questions and we can think about scenarios as well. So Toneshi says, how do you solve this? Subnet the class C IP so that you have at least two subnet. Each subnet must have room for 48. What are the two possible subnet masks? You just divide it into two. So /24 can be divided into 2/25. That is the next step we are going to do. So don't worry. Toneshi, let's do the next and last portion of today. Come again on that. 5 belongs to different subnet. So just like we discussed, this is one subnet, this is second subnet. So if you assign the IP address .5, it means they cannot talk to each other. Right? And Christian says, can you come again? Faisal says, please solve an example /16 to /23 with any IP address. Yes, then it will move to the next octet, but let's keep it for our next session, not now. Because it will confuse. But if you want to do it, I can do it with you. You can send me a WhatsApp message. We can do it as well together, right? So somebody gave us this network, this one. And he said that we have to divide this network into 4 parts, right? So this is the part number 7 of today, the last one. So we have to divide this one into 4 networks. How many networks are there actually? So there are 4 networks. Network number 1, where they need us to place 62. How many hosts will it give us, guys? How many hosts will it give us? Number of hosts are 2 raised to power 32 minus given mask, right? So is equal to 2 raised to power 32 minus 24. 2 raised to power 8, which gives us 256 IP addresses. So total, it means how many IP addresses we have in here? 256. So out of those 256, yes, there will be recording. Just like yesterday, admins will share the recording of today as well. So out of these 256, they want us to place 62 into this network, and they want us to place 62 in here. Then 62 into this third one, and then we need 2 IP addresses here because this is also a network between the 2 routers. Each port on a router is the part of a layer 3 network. Total 4 networks. It means we have to divide this one into 4 networks. So practical scenarios on your CCIE level, they go like that. But even if you don't understand this today, it's fine. You leave your things up to the range, that should be enough. But once you understand the range, then it becomes very easy for you to do this one as well, right? So I'll solve 1 or 2 examples with you. Somebody says, what is Mr. Don't says, what is VLSM? VLSM is variable length subnet mask. We discussed already that whenever an IP address is without a default subnet mask, it is called VLSM, variable length subnet mask. Other than 24, 16, 8, everything is VLSM for that range, for that class. Okay, so how do we do this one? Here we have to use a concept which is called as donated bit. It is a little bit complex. Let's do one example. I'll do with you. You guys try to follow, but first you start from point number 1. We had 7 topics today, so today and yesterday. So you start with from topic number 1 and do everything up to topic number 6. Then do it again, watch recording again, then do the everything, then do your home assignment, try to do the examples, everything, whichever are there in these slides. Also, these materials have been shared with you. Then you come to this one. So I would not suggest that in first go you try to do this one. Then it will look a little bit complex to you. Okay. So here what we have to do, we have to divide this one into 4 subnets. So how to divide? Let's do. First of all, we need to know what is our given mask. We already know our given mask is /24, right? So how many IP addresses are there? We already know 256. So here the value of H we have to calculate, because the value of H in this one is different. The value of H, how much is here? We already know. So let's calculate the value of H in the original subnet. This is the core of this one. So original H, and we have to find the new H. Means we have to find how many hosts are they requiring now. Once we find this one, then it becomes very easy, because we have to find the donated bit, and then the donated bit is equal to original H. These are some formulas, minus new H. So you find this one here, place it here, then you will find how many bits needs to be changed. Once we know, we can change it easily. So let's calculate. Let me show you how to calculate. How to find the original H, we already know. H is equal to, the formula is 2 raised to power H is equal to 2 raised to power 32 minus given mask. We already know what is given mask here. 2 raised to power 32 minus given mask is 24 in the original one, which gives us 2 raised to power, how much? 2 raised to power 8, and it gives us 256 hosts together. But what is the value of H here? The value of H is 8. Hosts are 256, but value of H is 8. Clear? Now let's calculate the new H. So new, what he wants us to do? He wants us to do 4 subnets. So let me write down here. So this is the original subnet, which is 192.168.0.0/24, which gives us 256 hosts, right? They want us to divide these 256 hosts into, let me make it red color, into 4 subnets. So each of them will have how many? So 256 divided by 4 is equal to 64. So this one will have 64 hosts, this one will have 64, 64 and 64 hosts together. So this is what they want us to do, and they want us to write that what will be the subnet mask, what will be the network number of all these individual ones, right? So we know that the original value of H is 8. So what it will be the value of in this new ones? If total number of hosts are 64, what is the formula for that one? So total number of hosts, again the same formula, 2 raised to power H is equal to number of hosts, which is equal to 256 divided by 4. It means 64 will be there in each of them. So 2 raised to power H is equal to 64. What is the value of H, guys? What should we place on 2 raised to the power so that it becomes 64? We have to place here 6 so that it becomes 64. It means the value of H is 6 now. Clear up to here? So we have to calculate the original value of H and the new value of H. New means these new subnet, that what will be the required value of H. Of course, if 2 raised to power 6, then it will give us 64 only. So we came to know from here. Once you become experienced, then you will know by heart. You don't have to do this calculation, right? So we have to divide this into 4. We found the original H, we found the old H, and then we just replace the values of H one by one in the original one. We will found the network numbers. We will found everything for these new ones. Let me delete this one to give us space. They are saying, how did you get 6? Okay, Idris, we got 6 because, for example, if I tell you to h raised to power x is equal to 2. So what is the value of x? You can get the logarithm first of all, or you can just guess it yourself. If I place h raised to power 1, it gives me 2, because if I place h raised to power 2, it gives me 4, which is wrong. So I have to get 2. So this equation becomes correct. It means the value of x is equal to 1. If I tell you 2 raised to power 7, or if I tell you 2 raised to power x is equal to 4. So what is the value of x here, guys? X will be, of course, x will be is equal to 2, because if we make 2 raised to power 2 only, then it will become 4. So clear on this point that how we got 6, right? There was a typing in this one. So in this one, so please ignore in the recording. It should be 2 raised to power, not h raised to power. Okay, also this one should be 2 raised to power 6. So it means h is equal to 6. We found from here, and the original h was, the original h what we found from here was 8. Now very easy. We have to find the donated bit, right? So we already saw that donated bit is equal to original h minus new h. So donated bit, let's write it db like that. So db is equal to, original is how much? 8 minus this one is equal to 6. So value of db is equal to 2. As soon as we know db, then the remaining things become very easy. So now we have to calculate the new subnet mask, because of course it cannot be /24. It has to be 25, 26, something more than 24, so that they become small subnet. We have to find that one, which is very easy. So new, so let me give it a different colors. So new subnet mask will be, this is step number 3. So new subnet mask will be is equal to original mask plus donated bits. So original given mask plus donated bit. So original mask was how much? 24 from here, right? And then donated bit is how much? 2. So it means the new mask is going to be /26 with all of them, right? Now very easy. So we start writing our new subnet masks, new networks. So the new networks, let me write with a different color. The new networks will be like that. Yes, it is too complex, Dante, but this is the only easiest method. If you try some other methods, they will be even more complex. There are many methods. You can try any other method as well, but then you can come back to this method. We will do another example, Toby, I think, after this one. For the new host, not new host, it is the new subnet mask. So original 24 plus donated bits, these two, it becomes /26. So as soon as we know that it is /26 and 2 bits needs to be changed, so let's keep on changing 2 bits and we will know everything now, right? So let's calculate, let's start writing our new subnet masks as well. So what is the original network? Original network was 192. I'm not writing in binary. The first 3 are going to be same. 192.168.0 dot. Original was 0.000.0.0.0.0. And it was /24. Now how many donated bits we found? There are 2 donated bits, right? So /24 means that this portion is our host portion. So in the host portion from leftmost side, we have to change 2 bits, these ones. These are our donated bits. we just write all possible combinations in here. We will find everything. We will find our subnet mask. So first, this is the original one. So what are our 4 network masks? 192.168.0. These two we have to write 00. 00, 00, 00, 00, 0. So we write all 4 possible combinations. Let me write first 00. Second will be 01. Third will be 10, and fourth will be 11. Then remaining will stay same. So 192.168.0.00, everything gonna stay same. 192. So these are our 4 networks which we have divided the original network into. 168.0.0000. So these are our 4 subnet masks. Of course, these are 192.168.0. Let me write those ones because the space is less now. Let me write in here. So 192.168.0.0/26, because we know from here that it should be /26. Then the second one should be 01 is always 1. So 1/26, then 2/26, then 3/26. These are our 4 networks. So it means, let me delete everything else so that we go back to our original things now. Then you will get the concept that what we have done, if we know the overall picture, then it becomes very easy for us to understand. So what we have done until here, we were given, they had given us one big subnet mask. This one big network of 256 hosts, which was 192.168.0.0/24. And it was giving us how many hosts? 256 total IP addresses, this one. They told us to divide into 4. So we divided into 4 networks. Each of those networks are these ones. 192.168.0.1, sorry, 0.0/26, which gives us how many number of hosts now, guys? This one gives us how many /26? 2 raised to power 32 minus 26, which gives us 2 raised to power 6, which is equal to 64. So this gives us 64 IP addresses. This is our first one. The second one is 192.168.0.1/26 gives us 64 IP addresses. The third one is 192.168.0.2/26 gives us 64. So this is how we can convert .0./26. Now what we do, we just assign these networks any IP addresses we can use. If we have to give to 4 networks, the network number is this. If you want to know the ranges as well, you know how to calculate the range. So you can calculate the range for this one, you can calculate the range for this one, but we can use our calculator as well. So let's go back to our calculator. Sorry, we converted it wrong. It is not 0. This one is 0. The second one is going to be 64. Third one is going to be 128, and third one is 192. So this one is not 0, 1, 2, 3. So this is 0. This is 64. The third one is 128, and the fourth one is 192, not 3. So these are 4 networks which we have divided into 4. Should we do one more example, or it's okay if it is too advanced for you guys? I think we can stay until range only, and this one you guys can do after the range, or we can have another session. So now what we do, we just take those IP addresses, these IP addresses, and then we start assigning. So how should we assign now, guys? So out of this one has given us 4 networks, right? What are those 4 networks? 192.168.0.0/26. 192.168.0.64/26. 192.168.0.128/26, and the fourth one is same 192.168.0.192/26. So this has given us 4 networks. So what do? We assign the first network to here. So it means even you don't understand the calculation, no problem, just understand the logic from here. So it means the first network we will give to this network 192.168.0.0/26. The second network, let's assign to here. The second network will be 192.168.0.64/26, and third one will be .128/26, and the fourth network will be here because here we also need an 2 IP addresses. So that one will be from 120 up to 192.168.192/26. It means now which IP addresses you can give to these hosts. So you can give them, the first computer will have an IP address of 192.168.0.1/26, 0.2/26, 0.3/26 up to 0.63/26. Then once you come to this network, what should be the IP address of the first one? It will be 192.168.0.65 because 64 cannot be used /26, and last one will be what? .126/26. Default gateway popular, you can put any default gateway. Whatever IP address you put here on the router, so that should be the default gateway for all of these. But of course, it should be from the same subnet. It should be anything 192.168.0. anything from 0 to 63 with /26. Why /24 as, oh sorry, it is 26, not 24. All of them should be equal subnets. Another important point, guys, whenever you are dividing the networks, you have to divide them in equal subnets, in equal subnet mask, in equal quantity. So you cannot divide a network into, if I tell you to divide this network into 5 networks, this is not possible. So this network can only be divided either into one network, which is this one itself. Either it can be divided into 2 networks, 4 networks, 8 networks, 16 networks, 32. You cannot divide any network into anything other than the powers of 2. You cannot divide this network into 3 networks. It's not possible. Cannot divide it into 6 networks. It's not possible. You can only divide into 2 raised to power. But what you can do after dividing this one, let's say you divide, let's say you can do this thing to do the optimal subnetting. So you can divide this one into 2 subnets of /25/25, right? But then further you can divide this /25 into /26, 2 more /26. So you can do this thing, but you cannot divide into other than the power of 2. Clear on this point, guys? I think let's not do many examples here because it is looking complex. Let me show you the calculation which are already there so that it doesn't look more complex to the guys. So let's go to another example, easy one. Here, what we have to do, then I can take your question so that people who have to leave, they can leave as well. So we have to divide this network into 2 networks. This example is more easy than the previous one. So what we have to do, /24 means it will give us 256 hosts, out of which we have to give 126 in here and then 126 in here. So very easy example. Let's see how do we calculate this one. Yes, there is. Theo, you are right. Very good. There is the first and last IP, which is network number and broadcast number. But I will take all your questions, guys. Let me unmute you one by one, but let's keep everything which is relevant. We'll do a revision and then we'll take your question. Let's go through this example as one because it is written clearly. Maybe my writing was not so clear. So let's see here. Then your logic will be more clear. Can we give 2 subnet behind one network? Yes, you can. Kuram, yes, you can. So they told us to divide this network into 2 networks. Of course, what we have to do, step number 1, we have to know what is the given mask of this one. So given mask is 24, it is already written here. No need to worry. Then step number 2, we have to calculate the donated bit, right? That how many bits should be donated. What we have to do for that? We have to calculate the value of original H and the new H, required H value. Original we already know, this is 24, 2 raised to power H is equal to 32 minus 24, which gives us 2 raised to power 8. It means the value of H is equal to 8 and required number of hosts in the original one, given number of hosts are 256. Now the point is to calculate the new value of H. So how to calculate the new value of H? Is total are 256, right? So we divide this 256 into 2. You can see here we are dividing by 2, not by 4, because they told us to divide the network into 2, not to 4. Then 2 raised to power H is equal to 128. Value of H is equal to 7, because 2 raised to power 7 becomes 128. So it makes it very clear as well. So this gives us like that. Right, so now we know the original value of H and we know the new value of H. So what is donated bit? 8 minus 7, original minus new. So it means 1 bit should be changed from the host portion, from the leftmost host portion. Now very easy, what do? We write the original network in here, which is this one, 192. I have just converted this 192.168.0.0 into here. So how many donated bits are there? There is only 1 donated bits. So it means we change only 1 bit. Put all possible combination. First we put n is equal to 0, then we put n is equal to 1. Then we convert to our normal number. So 192.168.0.0 and the second subnet will be this one. So we have divided, what we have done here, we have divided this big subnet into 2 smaller subnets. First one is this one and then the second one is this one. Clear on this example, guys? Let's move to the next one. Any question here? Let me see your question which you guys have written. I think from here your concept will be more clear. Okay, Philippus says, if I miss any question, you can paste again. Philippus says, on the first network, are we not supposed to end up to .62 since the last one can't be used? No, Philippus, we have to write all the IP addresses, whether we can use or not. Usable IPs is something different. Total number of IPs is something on which we should focus, because we cannot remove 2 IPs, then the calculation will be wrong. So we have to calculate everything, but we already know first and last cannot be used. Right. Honesty says, I have a question. Sure, Honesty, please write your question. Richard says, please, we have to practice it via automation so we would know how to apply. Yes, that is better. Better you practice with calculator and then do it yourself on the paper, then you will know everything. Then watch the recording again and again. So you have to watch at least 5 to 10 times this recording and do your practice. Subnetting is not something somebody will teach you and you will understand. Otherwise, you know, until today, you were not joining this session, you would have already understood the subnetting, which you joined many sessions previously in your whole life, in your career. I'm talking to the experienced guys, not the new ones. So subnetting is something we have to spend some time. Khurram says, can we give 2 subnet behind 1 router? Khurram, your question is not relevant here, but let me answer. So you are saying that we have 1 router, can we host using 1 port or not, right? If this is your question, then the answer is no. As soon as you assign the first IP address to this port, if you assign this one, because you have to give an IP address, 10.0.0.1/24, it means anything which comes behind this one, either there are 100 switches, 100 networks, all of them should have to be within the same range. So if it's still not clear, please write your further question again. Khurram, I think it's the thing you are asking. Theo answered to gift. Khurram says, can we give 2 subnet behind 1 network? I answered already, okay. Parent says, at what point do we use these in real life? Parent, this is the real life which we just discussed. You will face this one when you are working in your real network. They will tell you to divide this network into 2. This will be your real network requirement. This is what we are doing here in MTN as well. Toby says, now I get how you get your new host. Okay, very good. Kamiru says, how did we get the new H? New H is 2 raised to power H. This one. So we already know that 256 needs to be divided into 2 networks because this is the question. So 256 divided by 2, which gives us 2 raised to power H is equal to 128. So you need to think which value you should put here so that it becomes is equal to 128. Of course, this should be is equal to 7. Then it becomes 128. So it means the value of H is equal to 7. Clear? And what is purpose of broadcast IP? Khurram says broadcast is a special purpose IP which addresses to all the hosts in the network. Babar says where /31 network are used. /32 is a loop back. It means we usually use it on the virtual IP address on a router, which never goes down. We use it for special purpose. Which one are you saying? Yes, this one is a typing mistake, guys. This one should be minus, original minus new. Thank you, Aliu, for pointing out. And then Khurram says in live environment where usually, okay, I answered. Nuruddin, typing error in the formula should be minus. Okay, very good. So I can see there are no more questions. Let me do one more example and then we revise everything. And then I take your questions as well. Then there is a home assignment, guys, after this. Okay. So this is how this network has been divided, which we just discussed. Now let's go to another example I have done for you. So here they are saying that this is the network 192.168.0.0/29. We have to divide it into two networks, this one and this one. There are two host IPs required in each of them. Can somebody tell me how many IP addresses will this one give us? How many hosts, maximum number of hosts? Very good, very good. Some guys have got it already. Yes. So 29, we already know that number of hosts is equal to 2 raised to power 32 minus subnet mask. Given subnet mask is equal to 2 raised to power 32 minus 29, 2 raised to power 3, which gives us 8. So it means this original network is giving us 8 IP addresses. And they are asking us to divide it into further 2. So we have to assign 4 IP addresses here and then 4 IP addresses in here. So very simple requirement. You can start with this one, right? So what do we do? All the same steps again. We have to find the donated bit and then substitute the possible values in that donated bit in the original network. That's all. It will give us the original 2 networks. So we calculate the donated bit. Original value of H, 2 raised to power 32 minus given mask is H is equal to 3 and total hosts are 8 in the original. So it means the new 2 networks will have how much subnets, how many IPs in each of them. 8 by 2 is 4. It means H value is 2. So original is 3 and this one is 2. So original H minus new H. This is minus, guys, not plus. So typing mistake. So 3 minus 2 is equal to 1. Then the original subnet mask will be how much? It should be added with donated number. So /29 plus 1 gives us /30. So new subnet mask will be /30 and donated bits is 1. So we have to calculate 2 things, very easy. Calculate the donated bit and calculate the new subnet mask by adding this donated bit into the original one. So we found it 1. We added into 22, 29, we got 30. So we got these 2 things. What do we do now? We write the original subnet mask in binary. And then we know that the original was 29. It means there were 3 host bits. Everything else was network bits. So these were network bits and 3 were host bits. So we changed these 3 host bits from the leftmost with the donated bit. So there are 2 possible values because donated bit value is 1. So first value is 1, the 0 and second is 2, 1. So 192.168.0.0 and .0.4. These are the 2 networks. So we have divided this very big network into these 2 small networks. Each of them will give us how many IP addresses? 4 and 4. 2 will be usable. Clear? So now there are some. So let's revise quickly. So we have studied yesterday and today about IP subnetting. Then I will unmute you one by one to ask your questions so that it clarifies your concept, and the people who have to leave, they can leave as well. So let's summarize quickly. Galaxy S8 Plus, please write your full number with country code so that admin will share the detail of the full training course with you, because I saw you are saying you are interested. So IP subnetting, We discussed yesterday and today total 7 topics. The first one is about fundamentals, second was about IP address classes, then conversion from decimal to binary, and then back from binary to decimal in point number 4. Then we calculated the maximum number of hosts in a network and the range of IP addresses, and then some real world scenarios which we did today as well. So let's summarize quickly each of them. So fundamentals of IP subnetting, we have 2 parts of IP address. The first one is IP and the second one, the IP itself, and the second one is subnet mask. IP address tells us that what is the number of the host, while the subnet mask tells us that from where does it belong. For example, if we see this whole network, then we can easily identify that from where does this IP address belong to. Of course, this one belongs to network number 2 in here. Why? Because the range is this one. So we need subnetting so that we can decide, we can define the boundary of our networks, right? Using the subnet mask and the network numbers as well. Then the current standard of IP is RFC 791. I would suggest that you guys study this one in detail. And the IP is a 32-bit number. It has 2 parts, which is network portion and host portion. It is represented by dotted decimal notation. And the IP address, if it is found with the original default subnet mask, it is called classful. If it is found with any other subnet mask, it is called as classless. First and last IP address cannot be used. We have studied this in detail. Now you understand this point. I think you understand all of these points now, right? If the subnet mask can be written, IP and subnet mask can be written in binary and it can be written in normal numbers as well. So we saw the example of classroom. So for example, we have a CCNA batch which is running currently. So we write the roll numbers of the classes in this format. This tells us that the first few digits, first few numbers are fixed and then some numbers are changing. The same thing is with IP address. Some numbers will keep on changing, which is called as host portion. Some numbers will be fixed. Now, after doing all the practice, if you see this example, you will understand everything, that the host portion 192.168.0 was fixed, while the last number will keep on changing. For example, if we have 10.0.0.0/20 or /30, if we have this subnet, so which IP addresses will be this one, right? So this one will give us the first IP 10.0.0.1. The second will be 10.0.2, 0.3, 0.4. So you can see that when we start from first to last IP, there are some numbers which are changing and there is a portion which is fixed, right? Now you compare this one with your decimal numbers, then you will understand. Is it better now, guys? So this is called your host portion. This is called your network portion, right? This is how it works. You guys can easily study. So also we can divide the networks. The purpose of subnetting is to divide one big network into 2 small networks so that we can use them, or combine the 2 networks into one if our requirement is like that. So you should know that how to divide these ones. For example, if we have so many students in one class, of course we cannot house them in one class. So we have to divide them into 2 classes for easy management. 100 students will be 50 in one class and 50 will be in the second class. So similarly, if our requirement wants us to divide a network into 2, 4, 16, then we can divide them as well. So we have this /24. You already saw that how we divided with the help of the donated bit. So we divide it into 2 networks with /25 and /25, 0 and 128. Now we already know that how to do the ranges also. I can see some people are writing their number. Guys, only write your number if you are interested in full training course, or if you want anything, please also write, I want free study materials, or I want this and that. If you just write the number, it is not useful. Please write if you want full training course of CCNA or CCNP or specialist, so that admin can share the information with you. Please write your full number. Not the half. Okay, so why we need subnetting at all? We need subnetting for easy network administration, for better network performance, for improved network security. For example, if we have this large network which gives us 256 hosts, we already studied and we know now how to calculate this one. So we will assign out of these 256, 30 here, 27 here, 30 here, but of course we will assign them either 32 or either 64. We cannot assign 27. So in that case, 5 will be wasted, which is normal, right? So after that, this is how we got 5 subnets and we assigned everything as well. We assigned all of them. Then we have IP address classes. So totally there are 3 classes, class A, B, and C. And this is the default mask. How do we identify? From the first octet we can find if it is between 1 to 126, it is class A. If it is between 128 to 191, it is B. There is class D and class E as well, but we don't care about them because they are not involved in subnetting. And then this is the default subnet mask. It means if there is an IP address which is 10.0.0.1, it should always come with /8. Then it will be called as classful. But if this is found as with any other IP address, with any other subnet mask, sorry, if it is found with /9/10, then it is called as classless. So this is the difference between classful and classless, right? Then these are some exercises which you guys have to do. Now then we also learned how to divide, how to convert decimal to binary. And section number 4, we also learned how to convert back from binary to decimal. So it was very easy, I hope, for you guys. Then we just write our old school method. We write in this format, we keep on dividing and we keep on writing the remainder on our right side as well. So then we keep on dividing. We went through some examples as well. I want you guys to finish these exercises as well. So then we learned binary to decimal conversion as well. Right, so we write these numbers, powers of 2, and then we multiply and divide them to find our decimal number. Then we discussed in section number 5 how to calculate the maximum number of hosts. Very simple, now everybody knows about that. 2 raised to power h, which is equal to 32 minus given mask. So we just subtract this number, from 32 and make it 2 raised to power, so that it gives us the idea. It gives us the number. And then out of those, we have to minus 2 always, because first and last one cannot be used to get our usable IP addresses. Then in the last one, in the 6th one, we calculated the range of IP addresses. What we have to do, we simply have to write this number in binary and then write this number in the forms of 1. We multiply bit by bit, and it gives us the first IP. Then in the first IP, we calculate the value of h, and those h bits have to be converted to 1, which gives us the last IP address. So from first to last, we already know what is our range. Once you do the practice, then it will be easy for you guys to go through it. Then in next section, we went through some scenarios as well, that how to divide. If a special requirement comes to divide a network, how do you plan that? For example, if somebody tells us to divide this one into 2 networks because they don't want all 256 hosts to be wasted on one side and then they buy another host again. So they told us to divide into 2 networks, 126 each. So we said, yes, it can be done very easily. We found our donated bit with the help of new and current value of h. So original value and new value of h, we minus them. This is minus, and then we get the donated bit. This donated bit we add to the original subnet mask. We get the new subnet mask. Then in our host portion, we know that the original was /24. So it means 24 bits were the network portion. So in the host portion, we start from the leftmost side and start substituting the values of donated bit, all possible combination. If the donated bit is 1, of course, it gives us 0 and 1 only. If donated bit is 2, it gives us 0, 0, 0, 1, 1 0 and 1 1. If donated bits are 3, it will be total 8 combinations. The first one will be 0 0 0, second will be 0 0 1, 0 1 0, 0 1 1. You already know it, we did it in our school last time. 1 0 and 1 1 1. So it will give us 8 subnets. This is how we can divide the network. So if we are given this big network like this, we divide it into these two small networks, and the host IPs have also been divided into two. So thank you guys. Thank you for joining.